Reflection is on its way to Clang, I think. It's already in GCC, the latest version, 16 point whatever, point 1, I think, has Reflection working. So there's this nice talk from CBP Now from 2 weeks ago that I've started watching, and I'm just going to continue watching it because it's awesome. It again goes over Reflection and a few things about it. Eating my spaghetti as well at the same time. So where is it? It's here, yeah. Also, shout out. Oh my god, bro, Switch. I recommended this guy's videos. He's a series where he's literally just writing UI library. Well, it's called Writing UI Library While Unemployed. He's on part 9. I think this might be misnumbered. But yeah, that's
first.
Awesome. Yeah, he's using C line, I think, but
it still stood vector based. I don't know.
Yeah, on macOS.
And
but yeah, just cool to see video. I mean, not too dissimilar from mine, but probably a lot shorter and also probably a lot more productive in terms of actually creating things. But yeah, it's just cool to see. Anyway, this is it. It's a keynote presentation. I'm actually like 40 minutes in. I thought I was less. Yeah. I'll link this video in the description because you should watch it if you're interested in Reflection. I think it's a cool talk. Guys, it's very funny, so makes it nice as well. And he's just compared it to Rust and Swift as well. That's the context. And let's continue. I'm sharing my screen, right? Yeah.
And I'm going to start talking about TupleCat. All right, this is an algorithm that we've had in the standard library for a while. This is the complete specification of it. And if you look at it, it looks like super daunting as a specification. We're introducing 8 different variables. We have both superscript and subscripts going on in this definition. But like ultimately, TupleCat is not a very complicated algorithm. Ultimately, we're producing some specialization of tuple, where the types come from the tuple elements of each of our arguments, going down the list in order, and the expressions correspondingly come from calls to get. And so if I walk through kind of a simple example, let's say I have a one tuple, a pair, and an array, which are our 3 kind of tuple-like types. We need to produce some kind of tuple, and the first argument is going to give us one type and one expression. The second argument is going to give us those 2 types. And for the array, we're just going to get d 3 times and those 3 expressions.
Okay.
Of course, the expressions are actually going to be calls to get, but I think this is a little bit easier to reason about. And so note that we're preserving the reference from C, but the other ones are not reference types because those are the actual element types of those tuples. And so you can think about, it's like, okay, well, what is this algorithm? Well, we're going to walk over every argument, and then for each argument, we're going to walk over the elements of that tuple, and that's how we build up this structure.
Okay, I mean, obviously it can do that, but I mean, like, I didn't know there was specifically a standard library function for that very thing. I never use tuples. I don't know who does. I find them to be quite annoying. I prefer to use structs, but it's interesting.
But how do you actually implement that? Like, that's the algorithm. But step 2 is like, okay, but how do I conform this algorithm to a way that actually works? And so the best way I know of how to implement TupleCat, at least in the C++ we have, which I think Peter Dimov came up with this approach, is so you start by numbering your arguments. For each argument, you produce the sequence of indices into that particular argument. Then you extend the upper list to be the same length as the bottom list. And what you end up is 2 lists of the same length. And in this particular case, we have 2 lists of size 6, 2 lists of integers. And that is the size of the resulting tuple, right? I'm producing a 6 tuple, six tuple. And what having these 2 lists together give me is a way to do a single path expansion to produce the resulting tuple, right? Because we don't have iteration, we have path expansion. And if we want to avoid kind of piecewise putting together tuples one at a time and minimize the amount of copies and moves we have to do, we really want to produce the whole result in one go. And so we can do that. We can write a meta function to turn a tuple into a list of its corresponding types, which of course, again with MP11, we really want to live in a type-based world, and even though tuple element t exists in the standard, it takes an int, and we need it to take type, so we kind of have to wrap that. And then we can do a bunch of metaprogramming to produce the tuple number list, which is our inner list, and we can do a bunch more metaprogramming to produce the outer list. And like you can do this, and I have mentioned that I like MP11, it's a good library, and it makes this as easy as possible, I guess. And with C++ 26 now, We even don't need inner and outer to be typed lists anymore. We can actually unpack them and use patch and structure bindings and make them context first, so that inner and outer are now actually those lists of integers that we want. And so then ultimately we can produce our tuple in one go. And so this is kind of nice. We can actually finally implement tuplecat in one function template without any indirection. Of course, I needed those 3 other alias templates out front because I needed more work, and we can't have local alias templates. And this doesn't really resemble the original algorithm I talked about in terms of like walking through the arguments and then walking through the elements of those arguments, but it works. This is certainly a solution. But what could it look like if we actually could just put together the pieces that we need to put together? And so, let's kind of borrow this Rust idea of
it's insane how much more accessible the metaprogramming becomes. Like before, I don't know I'm not familiar with the MP library anyway, so I couldn't really speak on what MP product or MP iota or MP apply does, or MP append. I mean, I'm guessing it's apply, append, transform, integer. What is iota? I don't know actually. Sounds familiar though. I don't know why. But it's like you have to get all these different templates with using and that. Like it's a very hacky way to do it. Like maybe it works, but it's not how you want to do it. And it's kind of like learning a whole other language in of itself.
If we actually could just put together the pieces that we need to put together.
In that sense.
And so, let's kind of borrow this Rust idea of having just raw sequences of tokens. What we can do is we can start by, we have an array of our reflections of all of the types of our arguments. And we're going to build up two vectors. The vector of C types and the vector of the expressions that we need to produce. So C.
Literally. It reads how you'd want it to read as well, which is how an algorithm should read. Like an algorithm should read the way I intend it to be. Well, the way it literally is. Like that's the algorithm. Right? You're writing those instructions.
C types and C elements are the names that the spec happen to use. Types can just be reflections representing types, and elements are going to be our token sequences. These are the expressions that I want to put there. And so I'm gonna have my 2 nested loops, right? I'm gonna loop over the parameters to tuplecat, and then for each parameter, I'm gonna loop over the number of elements. The next type is just the kth tuple element of that type. And now maybe the next element is going to be this expression, right? I need some call to std_get with an appropriate value on the appropriate tuple. And so this might produce the token sequence, something like that.
What does \that mean? I don't recognize that. Yeah, I don't recognize that at all actually. Size of tuples ... That's interesting. Yeah, so I don't fully understand I've used ... for variadic arguments. I don't fully understand what size of ... would mean in this context. Like the size of the tuple list, like how many tuples there are? Or like, is it the elements in total? I'm guessing it's the size of the expansion, right? So it's like how many expanded elements are there? And I wonder, and then like, is that built in? Like, is size of ... a specific thing, or is that part of the language? I don't know. But yeah, variadic arguments are always interesting. Not ideal. And then, but it's cool how we just have yes, everything is context pairing, constable, whatever, but we just have a vector, right? And we can use a vector, which is quite natural, so we have these loops, we have actual loops as opposed to recursion or whatever. And then we are pushing back into our vectors. So you push back a tuple element, k archetypes. I don't know what tuple element does. Maybe he said it. But then we this is the confusing part, right? The actual reflection going on. So we have this operator, which means to get the type info of, I think, like the meta reflection info of. I believe this operator returns standard meta info, and it's a scope, which is interesting. So why is it a scope as opposed to a just normal brackets, parentheses. Then standard get, again, I don't know what the backslash means. Like maybe this is standing in for something. I don't know. And then we have another variadic unwrapping here. So
I'm interpolating K and I here to produce my token sequence.
Can I ask what is this backslash?
So backslash is, we need an interpolation syntax. So Rust uses hash for that. We obviously could not possibly use hash because the preprocessor claims it. And so one of the issues in this world is like, well, you need some syntax to do interpolation, and that syntax cannot clash with anything that is valid C++, because we want to be able to inject anything that is valid C++, which sort of limits the syntax options available to us. But backslash happens to be available, so that's something that we could do.
But to make it clear, this token sequence stuff is proposed. It's not actually in C++ 26.
Right, this is not in C++ 26. For that matter, it may not ever be in any C++. So this is we're just doing a thought experiment here of what it might look like.
Okay, so this
is the expression that we want to write in our.
I mean, this is standard. This is standard. Yeah, like this syntax, I don't. But okay, so it's interpolation. Like in what sense? Like this becomes 1 TS2. Why can't you just insert that normally? What's the interpolation for? Like in Swift, it's string interpolation. Like it's pretty clear. This doesn't look clear.
Okay. Right, like we want to produce this sequence of expressions, these calls to gets with the right indices. And once we have these two things, well, we have substitute already to produce the actual return type of our tuple. That is in C++ 26. And we need to join all of these expressions with a comma. That is not in C++ 26. But once we have this, we just need to inject this right return statement for us, right? Because we're just returning this particular tuple with this set of expressions.
Okay, I see. So it's specifically the token manipulation, right? Like this comma thing is literally inserting a comma into the token tree, kind of. The token sequence, not a tree. That's different. So is that how Rust works then? Interesting. Is this necessary though? Like my issue with with Rust macros, for instance, proc macros, whatever, is that they are literally too powerful. And like I know like it's good for a feature to be powerful, yes. People have the same thing about templates, C++ templates, right? But like at least with C++ templates, it still feels quite natural. Like the interface will always seem quite feel natural, right? Maybe like the way that you can use templates to implement things is not natural, as you've seen with like reflection strategies, before C++ 26. But the API itself is intuitive, right? Like you just call a function and you have the template. Like that's kind of how that works. But I mean, again, like I'm sure you could abuse it, but even then, therefore, templates aren't perfect. But like my issue is, I don't like how, for example, you can have a whole DSL within Rust. Some people like it, but I don't like it. I'd rather write Rust code in Rust, right? Or like when I'm using Rust, I use Rust code. I don't want to write HTMX in Rust. If I wanted to do that, I would rather that Rust was designed in such a way that it literally did that naturally without needing to rely on macros that literally parse like a whole other language. Like that manipulation of a token tree, which then has like a token sequence, which then has the AST, the abstract syntax tree. It's I don't know. It's not my preferred method, let's say, because it can make like not only can it make for some really goofy API that I don't agree with APIs, but it has like with Leptos. I don't like that. Like if Rust syntax is so problematic that we need those macros, that's a Rust syntax issue, and not really like that is a reflection of Rust having bad syntax. So okay, I mean I'm just saying because as I say this, I'm designing my own language, true, which first and foremost, before I go into like all the other aspects of it, first and foremost I want to focus on the syntax. It has other focuses besides syntax. Like there are other things that it achieves to do because it does want to be that like a systems programming language, so it has to be low level. But the first thing I want to focus on is having good syntax, because when you have good syntax, so many other language features become unnecessary. You don't need to have macros that make your syntax nicer because the syntax is already nice. You don't need like goofy like builder patterns, for instance, because if you have named arguments, so like it's stuff like that. And I really prefer that C++ did not go down this route. Yes, C++ syntax is fucked, but like I'd still rather write C++ than have these capabilities. Because like yes, we're doing it here for tuples, but this like kind of piecing together like the literal token sequences with like adding commas and everything, there has to be a way that doesn't rely on literally adding commas into the token sequence. Like there has to be some other way that is more natural.
And so if you compare this to the previous implementation,
so like my point is there's a reason you use a programming language, right? It has a predefined syntax that you probably like, you know, that has all these features. I mean, actually, to be fair, you probably don't like it because that's kind of the state of modern programming right now. People aren't focusing that hard on syntax, which is why I am making an effort to, because I feel like I want good syntax in my language. So like when you get a language, you know, you are agreeing, you're subscribing to a certain syntax, and you like that, and like you even if you have issues with it, you would appreciate the fact that it's consistent syntax, right? It's rules. These violate those rules, and I don't like that. I'd much prefer if you do not have the facilities to make a language within a language, but like in that language's source code. Because like then it's like, why are we even writing C++ anymore? Like just for the features? I mean, again, it's a flawed language syntax anyway, so you know, like there are arguments to be made there, but this is just yeah, I'm not a fan. I'm not a fan in general, but under certain circumstances, you can see why it would be desired.
You know, there's obviously some new stuff here, like what is this token sequence stuff? What is this new syntax for interpolation? But you know, I like this approach a lot better, and I don't like it because it's shorter. Like, I mean, it is shorter, but the fact that it's shorter is really a consequence of the real reason that I like it, is that it's simpler. I can just write regular C++. I know what algorithm I want to have to produce the result, and I just do that. So it's a much simpler model to deal with. And the consequence of just being able to write regular C++ is that I can just do this, right? We don't have any way to iteratively build up things in a template meta programming world. And even once we get into this frame, then we can talk about things like, well, why did you write like a regular for loop? Shouldn't that be enumerate? And like, yeah, probably should be enumerate. And we can talk about like much more interesting things than like, well, what are all these MP11 algorithms that you're using? What is even going on? Is this even possible to understand or debug?
Yeah. That debugging is actually a really important part of that.
If you're going to do this, why wouldn't you just go all Rust and just return a vector of tokens? If you like build it up fully, you know, put the return and everything else on it, and that would be a return type, and let the compiler sort of deal with that.
Yeah, so that's kind of what I'm doing here. So Q injection is just a function that takes the token sequence. So instead of having like a function that returns them, I'm actually passing it through to something else. I think that's just a question of like, well, what is the actual shape of this thing needs to look like? But the model is definitely the same thing. Okay. It's just like, here are these tokens. This is what I want you to put in at this close brace, and the compiler just does that for me. Yeah, Ben?
The token injection, is it automatically splicing R express?
Yeah, so in the way I'm thinking about it, because R is a reflection representing a type, and of course the compiler knows that. And so what you want here all of the time is I want that type. So what I wanted is just give me like a pseudo token, like a fake token, and what it is it represents that type. Like, don't make me spell it out. You know what it is already.
But there's not splicing k above.
It's not splicing k. So k is just an integer, and so
Sure.
what I get is that value.
There's no case where you would want it not to splice r?
Well, if you want it not to splice r, there is a case when you'd want that, but I think of that as being like the rare case. And so if you want to not splice r, you could just wrap r again with reflect constant. And I think in this context, like I think syntax is going to be very important, and you want the syntax to be light. So I'd rather the rare case to be like, okay, I really just want this to be a reflection, whereas the almost all of the time, if I have a reflection representing a type or a namespace or a template, like what I want to splice is that type or namespace or
It's a good
template.
argument.
I don't want to have to then splice it
It's
as
a
a result. It's
compromise,
just like more syntactic noise. It makes it harder to
It's a good starting
understand.
point.
Yeah.
Why not just string? So for interpolation, we just use std format, and it just gets a string return.
Honestly,
and,
not a bad idea.
yeah.
Right. Yeah. So that's a good question too. So of course Swift does use strings. So why not strings? And the problem with strings, I think, is I think strings have multiple problems actually. So first, I think dealing in tokens is easier for the compiler because it's going to lex them on the way in, and then it's done. With strings, it's going to have to relex the result. That's more work. The real problem with strings is like we just don't have good string facilities in the language, so that just inherently makes them harder to deal with. And our main string facility is format, which is great. But if you're using format to inject C++ code, the fact that format uses braces for interpolation means that when you want to actually write a brace, you have to escape it all the time. And so like now it suddenly stops looking like C++ code, right? You have all these double braces everywhere. It's a lot harder to deal with. It's not going to get automatically syntax highlighted for you, right? You can see that like my token sequences are highlighted for me when I paste them in, which is kind of like a nice thing. So I feel like for us, strings are just like strictly worse than having like a dedicated facility in basically all respects. Yeah.
Let me flip the question a little bit. Why are we messing with token sequences at all? Why do I care about the fact that my token sequence needs to be joined by a comma? I have a set of elements that are going to be a part of this tuple cat. We know that this is the set of elements. Why can't I just have a meta type that says this is my set of elements that I'm describing? Why do I need to retokenize it, feed it to the compiler?
That is a question that I am wondering. Also, as the more I look at this interpolation thing, I'm kind of seeing it more. So this is kind of like defining a pattern of sorts, where like I'm like this is almost like a string, and I'm interpolating the string to have this inside, right? Except it's just standard C++. I'm not like that. That is interesting, but also looks weird as hell. Like this isn't returning anything. Like it literally is injecting this expression, and then these are being interpolated inwards, right? Like we're just replacing this with replacing what's inside here with expression, and like that gets put into our code, if I understand that correctly, which is. It's preferred to strings. It is preferred to strings. You also could just write it like a string. Like you wouldn't really lose much there. You know, like if you use backticks, for instance, instead of whatever, or like if you had like these symbols surround both sides, like that was your token string. Yeah, but it's interesting, isn't it? It makes you wonder, like, in what other use cases is interpolation useful? Because, like, we do it for strings, because, you know, we work with strings all the time. But, like, are there any other cases where actually having interpolation, like, global, like, as, like, a global language feature would actually be useful? Plus, this idea of just passing around code like this is also interesting. Like, code that isn't executed, but code that is literally copy-pasted. I mean, it's like a macro, right? Yeah. My issue with this is that it's dangerously close, if not literally already reaching a macro system. Because the issue with a macro system is it exits the language and it gives you absolute control over the syntax. And that's, like I said, it's useful, it's powerful, but it's dangerous. One big issue that people have with C++ is that it gives you so many ways to do things badly, and it's pretty easy to do them badly as well. And this is kind of adding another version of that, because it's literally adding macros, like Rust style macros. Yeah, I don't like it. I think it defeats the purpose of like the whole idea behind reflection in the first place, which was that we can have metaprogramming without macros and staying within the language, no manipulating any syntax trees, like just getting info from the compiler. Like, if I'm looking at this right now, is there a reason I can't just create a tuple from the elements? Like, have some kind of generic, I don't know, some generic, like, list/tuple type, you know, like thingy that like iterates over them and gets their elements. So, for example, with the, like, I think with the example he had, right, he had maybe an element, he had a tuple of one element, I think. Maybe, or whatever. I mean, it doesn't really matter. A pair and then an array, right? Why can't I just write in a script, like write a metaprogramming thing that goes over those? It will get the types of each of those elements, you know, because like you can access an array, you can access a pair, you know, just like match on the type and then get whatever's inside, and then get the elements as well, and then just just literally just iterate over a tuple and then create. I mean, well, to be fair, I don't know how you can create a tuple in C++ anyway. Like, how do you create a tuple in C++ with a certain size? How do I say? Like for example, like if I wanted to do it with an array, it'd be pretty easy, right? You just add, like you just define the array of the size that you need, which you can get from the reflection, and then just, well, it'd be one type, so that'd be the type, and then you just insert the elements, right? Pretty easy. In fact, you could probably do that without metaprogramming even, because you just, yeah. For tuples, you don't specify the size like that, right? Unless there is a way to specify the size with tuples, I don't know. I mean, like, I guess the question is how tuples actually implemented. Let me just check that. Again, I don't use tuples. I don't like them because they're unnamed, but I guess it's similar to like constructing a struct. Almost. But how does a tuple know its size? You insert arguments here. So like you need some kind of way to insert those types. I'm guessing that's what he's doing here, but like, is there a way that we can do that where like we can just insert a variadic number of arguments and like get that instead? Like if it feels to me like we don't need this token sequence manipulation, you know, because like all he's doing here really is using comma and then standard get. What we need are better tuple and like variadic argument facilities. That's what I'm noticing here. So it's interesting, and I've had the same thoughts about my language. Like, do I even have variadic arguments, or do I say just use arrays? But then if I say just use arrays, then you can't have tuples, right? And like, what's a struct? You know, like, can I construct a struct from other elements? Like, can I do that? Like, if I have struct literals in my language, then I should be able to construct a struct through other means and return a struct, right? So in that case, how can I compose a struct? Like, those are things I need to look into as well. Or like with functions, you know, can I compose a function and then return that as a literal? These are interesting ideas. So let's see what he says about to this question anyway.
Like,
Can't we go with syntax trees, right?
yeah, why can't I just describe the abstract syntax tree directly or some notion of a syntax tree?
Keep in mind, that's not
Yeah,
the
so
question.
that gets into the question. That's I think a much larger question to talk about, and it gets into the question of like how, in order to get into a syntax tree, you have to have some notion of like, well, how do you parse this thing? And that gets into the question of like, well, C++ is very difficult to parse, and now we suddenly have to introduce all of these other types of syntax that we wanted to parse as. And so the question of like, well, what actual benefit would we get from having that extra stuff? And I'm personally I'm skeptical that there is much here. Like it's like, yeah, like okay, this is an expression, and I want a common set of expression trees, so like we can build up like a set of syntax types to do that. But like all I want to do is like produce this sequence of expressions, and I think the token sequences kind of get there.
So it's shortest path, right?
Yeah, it's just like I don't know that there's any much additional benefit to be gained.
I'm just wondering, like, are there any other use cases for this? Like for this token sequencing that isn't anything to do with variadic arguments? Like, can you do everything else you want to outside of like without this? Because then it really is just a variadic arguments thing. Now, could C++ fix that in a different way? I don't know. The language already has variadic arguments, so I'm not really sure what you could do there. Probably do some like funky syntax with the ... But I would like to look into that for my own language, right? And like just in general for language design for future languages would be cool. How does Rust even do? Well, I guess Rust uses macros for variadic arguments, right? That's why print line is a macro. Well, that and also the fact that it does format. Although a normal function can also call format, but that's besides the point. But then again, like, does format even need? Like, does format even? Sorry, does this format even need to be a macro if not for the variadic arguments, or is it just the variadic arguments that makes it a macro? Like when you look at Rust macros, like what's like when I think of, okay, how can I make a language that doesn't rely on macros? A good thing to do, honestly, would be to just look at Rust, look at Swift, whatever, look at C, and just think, okay, which features actually rely on macros, and do they need to? That's what I'm gonna have a look into after this.
Especially because just like in the Rust and Swift world, there's not much that I can check here. And C++ is actually even worse in the question of like, well, how much can you even check here? So there's not much that we're going to gain in the question of like making it easier to implement stuff.
One way to think about it is you have to standardize what are all of the tokens in C++.
I agree. Yeah.
Versus standardizing what is the syntax tree in C++. Versus standardizing what are all of the tokens in C++.
I agree. Yeah.
Versus standardizing what is the syntax tree in C++.
Yeah, it's the standardizing part, I guess, is the issue there, right? I mean, I don't really care. I think either way you should not do this, but yeah, C++, because like to my understanding, there is no standard for how the syntax tree should look or how the tokens should even look. Like, it is very much up to the discretion of the developer. But then the moment you open up your language to those features, then there actually does need to be a standard, and that could actually completely fuck over existing implementations. Like, imagine if GCC and Clang, I don't know if they do, but imagine if they have a different approach to the syntax tree and tokens, right? Token list. If suddenly like you need to have a standard way of doing that, they will need to rewrite like a lot. So that's interesting. Yeah, I mean, like I can picture a simple, token sequence and AST, in my mind, but like I'm gonna imagine that C++'s one is just like unimaginably more complex than that. Yeah, it's hard. Like it's although a lot of people see it as a lost cause, it is commendable that people keep trying to improve C++. And I think the work that is going into improving C++ is actually like some of the, if not the most important work in the programming language space, because like they're looking at issues that other languages haven't even looked at. Like it's kind of weird. Like, why don't other languages have metaprogramming or like have looked at reflection like C++ has? I think Python might though, but like it's just like that. But like it's because of the way that C++ has to do it, because of how it was built initially. Like Bjarne Stroustrup had a vision in mind, and he still does. So like that's what, it's getting the language closer to that. It's getting closer to that with concepts and reflection. Like these are things that have been, I think, in his mind since the beginning, at least a decent chunk of it. And because of that, because C++ has also has to be made backwards compatible, the way that it restricts the language, right, into having to implement features in limited ways, actually leads to more innovation and creativity, which is really important to study for the sake of creating better languages in the future. So it's so interesting.
And I don't think any two compilers have the same syntax tree for C++.
Certainly, it would be an abstraction across the compilers, not any one implementation. But yeah, I agree.
Yeah.
But it's a different idea. We just standardize string interpolation and compile time, like for at least basic syntax of C++. Can it work?
Well, the problem is so you have the brace issue that I mentioned before, because if we standardize string interpolation, that string interpolation had better look the same as std format, because otherwise what are we even doing? That'd be very strange.
No, I'm talking about Swift string interpolation, where you have placeholders with the code inside.
I want to hear his voice.
Yeah, I think that would be very surprising though, because then we'd have two completely different string manipulation facilities that ultimately are solving the same problem but in different contexts. I think that would be a little problematic.
I mean, I agree on not using strings. It's just the fact that strings are convenient to manipulate. That makes it quite interesting. There's something else.
About Swift string interpolation, where you have placeholders with the code inside.
Yeah, I think that would be very surprising though, because then we'd have two completely different string manipulation facilities that ultimately are solving the same problem but in different contexts. What are we? So you have the brace issue that I mentioned before, because if we standardize string interpolation, that string interpolation had better look the same as std format, because otherwise what are we even doing? That'd be very strange.
No, I'm talking about Swift string interpolation, where you have placeholders with the code inside.
Yeah, I think that would be very surprising though, because then we'd have two completely different string manipulation facilities that ultimately are solving the same problem but in different contexts.
I had a thought, but I just completely lost it. Okay.
Yeah, I look at this I am all for not doing tokens in, get away from the parsing, all that. I totally understand that. What I don't understand really, apart from its expedient, is not doing the same thing on the reverse, because C++ is not only difficult to parse, it is difficult to generate. So
look, I don't want to dog on anyone's voices, you know. I think accents are a beautiful thing, but there's just something about American accents that I just don't like, you know. And it's funny because I myself have a bit of an American accent, but I don't know, it just doesn't sound real.
If I have to think about, I have reflections of in the future.
Or maybe their intonation's just weird. I don't know.
Two expressions, and I want to produce their product. If I have to think about, this one uses a bit shift operator, and so I need to put parentheses around it in order to get the product right, I'm going to make mistakes.
The thought is coming back to me. Dollar, yeah, that's right. Okay. I was wondering, does C++ use $? Ever? Because I don't want to use $sign in my language, because, although hilariously I am now, but I'll sort that out. Because not all keyboards are guaranteed to have the American $sign. Plus, you don't want to rely on another country's currency symbol, for your language. It's kind of annoying, if you're American, maybe you are patriotic and all that, but for me, I'm not. So, does C++ use $sign? Is this is this a feature or just a suggestion? This is just a tuple. The @ symbol isn't used either in C++. I don't know why. Why doesn't C++ make use of $sign and at? $sign I can understand if it's not available on all keyboards, but at? I mean, at is everywhere, and like messaging apps have kind of made it a staple now because you can add people in messaging apps. C and the C++ restriction in its source character set to what was called the basic source character set. Oh wait, are they not in ASCII? Then US ASCII. What? What has at been remapped to? In the modern day, the symbol is so important as it is used for messaging apps and emails anyway. If there's one good thing about the internet being designed the way it was, is that email uses at, so now the at symbol is solidified. What? Sure, but see if I could add it as for a new C++ specific feature. No? Huh? Extensions. I don't understand that. Let me ask the server.
And like if you introduce variables and you also have to care about name collisions and stuff.
So I would be, I understand that it makes everything harder to implement and maybe even harder to learn. But I've got to say, I look at languages where you generate a language that is designed for humans to write with a computer. And the first one I think of is SQL. And when you generate SQL that is designed for humans to write with a computer, you make mistakes.
All right. Well, I'm gonna keep going in the interest of time. So,
is that a question or is he just talking? What the fuck's going on, dude? I love the way he mumbled through that in the interest of time.
All right. Well, I'm gonna keep going in the interest of time. So, let's get back to the formatting example I talked about before, because I talked about how we really want to get into a push-based model instead of a pull-based model. But we have annotation, so this is I think kind of the way that we have to move forward. Like we have these things, and so one way to do that is we could say that rather than trying to introduce a model where.
Okay, so this is the actual definition. Push-based formatting. I didn't understand the whole pull and push thing. I didn't quite catch that. He did talk about it before, but it didn't go into my head. Well, I'll just say for the record, I do wish it was not after the struct, to be fair. Because it just means that formatting your code is going to be a bit more of a pain in the ass now. Because do I put this here? Do I put struct this and then put that underneath? Or but yeah.
Okay, we're actually going to pass in the tokens of config somehow, or AST or whatever, into this annotation. We're just going to get a callback when the type is complete, and here's a reflection representing that thing. I think this is a model for us that I think is probably more viable long term.
Driver is a struct. I mean, this is if you do it in the Rust formatting way, right? But why is it a lambda, by the way? Like this is a function, right? But he uses lambda. I wonder why he's done that. I mean, I'm all for it because I do like this way of doing it, but like, why? Has he done it? Is this specifically to create a closure? Because there's nothing being enclosed, even. On that note, it is interesting how the closure in anonymous functions in C++ allows it to be used without like some other special syntax. Like this exact combination of blah, 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 of tokens, I guess, signifies a lambda. So like it's quite handy in that sense. Whereas if those weren't there, it would just be parentheses with like something inside, and it'd be a lot more confusing to parse. So that is interesting. Yeah. So debug is a function that takes the meta info and does something with it. But like what? Like do you access debug? I understand.
And so like, okay, so when this type is complete, we can go ahead and do something with that. And what do? Well, first we're going to require that this thing is a type, because that's the only thing that you can make printable. And at this point, we can do something similar. We can walk over our non-static data members, and we can produce that corresponding call to format2. We're putting together that string literal with dot identifier of equals braces and formatting that object. And note that like out here is a variable that I haven't declared yet. That will come in a future sequence. And this list builder type is just a convenient thing, kind of to a question that you did earlier. It's like how do I group these things in a more convenient way? I construct this thing with the delimiter because I'm introducing this extra comma space in between every token. There are several other ways to build it. This was just the first way I happened to think of. Yeah, Brendan?
Are you able to compile this code that you're showing today? Like, do you have an implementation of this?
Yeah.
Cool.
Yeah.
Great.
Wait, so this does work? Sorry, is this standard? Like, is this operator with the braces to get the tokens? Is that standard? Like, I'm actually kind of concerned now. And
so at this point, once I build up all of my fields, where I start with declaring out, like there's my original formatter, and here I need to remember to escape the brace because I'm using format, so I need that double brace. And fields is all this stuff I put together earlier. That's the calls for
queue injection with a template struct formatter. Yeah, I just don't know. I just don't know if I like. Well, I'm not sold on this approach. Right now, I don't like it.
For each field specifically, and then I just inject this into stud. Right, I'm injecting this explicit specialization into a different namespace. That's a totally reasonable thing to do because namespaces are open. I can add stuff to there whenever I want. And so this is my way of actually doing push-based rather than pull-based formatting. And so avoids that question of like competing specializations because this is now an explicit specialization. I never have this problem,
So thus far you've used queue injection on the namespace, which is open.
Yep.
Great. And on the function being currently defined.
Yep.
What do you do for classes or structs which are closed?
So same thing. So queue injection would inject into the context in which it's at. So if I'm building up a class, I can queue inject into the class itself because I'm inside of it right now.
Debug annotation was handed the completed class.
Debug was annotation of the completed class. So it is not allowed to inject something into the class. Okay. Classes are immutable. There's a whole class of problems that I'm not talking about today which are, well, how do you actually mutate the class that you're attached to? Because mutation is also something that we definitely cannot do in C++. We'd have to have a completely different model of things like the.
Yep, that's why I'm looking for that. Well, looking to see what that completely different model could be.
The metaclass model was not mutation. It's you grab this type, you hide it somewhere else, and then you produce a new type from scratch that has whatever changes you want to make. That's probably the way that we want to approach something like that.
Right.
And so, going to a slightly different problem is, kind of the pinnacle of the code injection problem is macros, expression macros specifically. And so I find that, especially in the C++ community, because we've had such a bad experience with C macros, that people tend to overgeneralize from that and conclude that all macros are bad everywhere.
Yeah, look. What the hell? I need to watch these documentaries, by the way. I still haven't finished the C++ documentary. I need to. Yeah. Abstraction, the choose it by C++. Yeah. Let's see what he has to say first.
Which I think if people have used other programming languages that actually have good macros, people like them because it turns out the macros are useful. And Swift and Rust both have a very good expression macros.
Yeah, so they're useful. But again, first of all, it's hard to understand them. Just knowing the language, like, I mean, I guess like with C++, you could, like with reflection, you could do it in such a way that it doesn't rely on like this special syntax. It just uses reflection features. But it's just like, it's more so just the fact that you can manipulate the language. How do I say this? It seems... Okay, the way it seems to me is that you have a problem in the language. And by adding macros, you're basically saying, I'm going to solve the problem of my language missing the features it needs to be robust by letting the user just manipulate the syntax tree or manipulating the token sequence, whatever. And it's like, well, you can do that, and then suddenly the language becomes like a super language, super, not stupid, super language that can do whatever you want because you can manipulate, well, I mean, within, I guess, some constraints set by the way the AST is read or whatever, but like, to me, if you need to go into a languages and manipulate its like token sequence or like generate a token sequence or like literally like do something with the language's own AST implementation just to get what you want, that is not good. Again, to me, it seems like a sign of a flawed language. So it's interesting that Rust and Swift are doing this because those languages are admitting that, yeah, we don't have the facilities to do reflection otherwise. I mean, it's why people are so excited for C++ reflection. Like one reason is a major reason is because it's like, yeah, well, Rust needs macros, but we don't because we have reflection. So what's interesting to analyze Rust, right, and learn from what it has done with macros to, again, like, as I said earlier, to see, okay, which features actually need macros and how can we fill those gaps through other means that are actually in the language, or like, I mean, not in the language, but like through the language. If you were to add features to the language that were like part of the actual language as opposed to like some kind of separate concept or construct, that would be preferred, in my opinion. But here, yeah. And like, it's just a thing of macros, right? Like macros are literally just a way to generate text or tokens, whatever, or AST, whatever, but like pre-processed. So before the language is running. And like that sounds like comp time, doesn't it? I don't think Zig as any macros. I wonder how Zig will do reflection. I'm very curious. I think Zig is quite interesting in that regard, if not ergonomic in a lot of ways. But yeah, I don't think we need macros. I think it's not that we hate macros because they're not useful, or like they are obviously useful. It's we hate macros because the way they are useful is really hacky, not intuitive, and is indicative that a language is missing some other features. That's my take on that. Yeah. So the question is, what else can you do it, right? How else can you do it?
Indeed, the example for Swift, if you look at the original talk that announced them, and even if you go to Xcode and you add a new macro, this is the macro that gets added to you by default by the tooling, is stringify. So stringify takes an expression and gives you a tuple of the expression and the string version of it. This is the kind of thing that you need a macro for because a function can't do it. And if you look at the way that this macro is implemented in Swift, it's very interesting in that it's typed. This is the declaration of stringify. It looks like a Swift function template. Indeed, this is what an equivalent function template would look like in Swift. The only real difference is that this one's declared macro and this one's declared func. The macro has this extra role at the front because it's an expression macro. And this is like a really interesting
external macro. Is it not defined within the language?
Consequence. And the Swift expression macros have this look and feel of Swift functions. The arguments to this macro are actually parsed by the compiler on the way in. Everything's type checked, but it is still a macro. So you can control what the resulting expression ends up looking like. And you can do something like, so to implement stringify, I'm returning again the string. That's going to be this parenthesized, comment delimited, the actual argument, and then the literal of the description, which is how you do stringify. Maybe a more interesting macro in Swift is a log macro, where we want to make sure that if I don't have this particular logging level enabled, that I'm not even evaluating the argument. So in this case, if I don't have debug logging enabled, I want to make sure that f of 1 isn't even invoked, but f of 2, of course, is, and I get that nice logging. This dot syntax is unrelated to macros. It's just a nice Swift mechanism to pass enums as arguments. Zig has something similar. It's a pretty cool syntax. And so again, the log macro is typed. It takes a level and a string. And the implementation is going to wrap that message in a lambda. It's in a closure. So we've kind of achieved that lazy evaluation.
Why did we even need this? I don't understand. How does formatter even work anyway in C++? Like, does it use macros, or does it just work? Because like usually you only format values, but it's not a compile time, right? So the value can't be known anyway, unless like it creates like a buffer to be inserted, and like has some like kind of like runtime mechanism that's, or or like it sets itself up for runtime so you can handle conversions at runtime, or something like that. I mean, I'm just kind of like thinking like how it could be implemented. I don't know how it is, but could also just look into it. But if only the library were easier. This is the side library. Well, the implementations were easier to read. Hey.
It's a lot of work to get to that laziness, but we've got there. And note that in the implementation here, we just have like these AST nodes that are our expressions. We don't have the types, we don't have the names of the arguments or anything like that. Of course, with logging, you probably want more information than this. You probably also want to add file and line information, which are other macro invocations, but we just inject the string that is that macro invocation, and then when that injection happens, those macros get evaluated as you might expect. And so when I add that, I can get also the function and line of my log, which is nice. Now, one of the consequences of this model that Swift has, where expression arguments have to be parsed, have to be part of the language, is that you can't just invent arbitrary syntax. So for instance, there's a proposal in C++ to add an implication operator. And of course, it's easy enough to implement an implies macro that is a comma b. and have that lazily evaluate B only when necessary. But let's say I just really like this arrow, right? And I want the macro to have this look and feel. I can't do this in Swift because this is not a valid expression in Swift.
That's good. That's good. Sorry, I can hear the cameras there. That's good. Can you do this in Rust? I assume you can. So maybe Swift is a better example of how macros should be, like in terms of how limited they are. Like because like the thing is, right? You can create a language that's as powerful as you want, that has all the features you want, that can do anything. But if it's not designed to restrict and like, because writing code, it's not just what you can do. It's also how you write the instructions, because ultimately this is being read by a human or it's being read by an AI, whatever. Code should be clean, should be well formatted, should be easy to read, it should be readable. These macro features exist mostly to make code more readable, because they're probably, I mean, like, there are other ways to get around it, but like, to do so is just so unergonomic. So if you can, like, we don't like the idea of restricting the programmer, to like certain possibilities, it's like, let people code the way they want to, whatever. But like, if you have a language, I like opinionated languages when their opinions are good. That's really important. Because then code bases are consistent and they're correct, and people don't do silly things that end up leading to horrific code that is horribly hard to maintain. And that's a good thing. Yes, it means you get like less fun out of it, like, I mean, like in the sense that you can't, have these obfuscation competitions like you do with C, to make like the most obfuscated possible C code that still does something cool. Like, those are cool, of course, and like for that reason, I guess C lands itself a place as an esoteric programming language. But like, when you're actually using a language to actually make things, the real fun, the joy, comes in writing programs and writing code that like is actually maintainable and approachable. Rust macros don't do that, I feel. And macros in general tend not to do that. Why do I even need this? Implies, I guess this is a bad example. So I'm very interested in ways to replace macros fully. I think Bjarne Stroustrup has said that it is a goal to completely replace C macros. Reflection is one step there, but there's other things though that only macros can do. For example, only macros can return implicitly. There's no other way to do that, to my understanding. I mean, like the standard exit, but I mean like return from a function and then like continue execution out like from that end of that call. Only macros can do that, to my understanding. And again, with like there is facilities for variety arguments, but they're not the best. So,
I mean, I can actually, in Swift, I can make that a valid expression because you can define whatever operators you want, and make this like only usable in the macro, and then the macro implementation just enforces that the expression has this shape. That feels kind of weird. I doubt anyone actually does this in Swift. What you could do instead is you could actually make this a string. And the implementation of the macro just parses that string and pulls out the A and B part as expressions. And
this I'm fine with, actually, because it forces you to still write it as a string. You may complain that like, oh, but I don't get that. But like, yeah. Like you don't get the highlighting, whatever. That's good. If you want to parse a string. But like if you're just putting like random symbols to the code that isn't from that language, it doesn't belong in the language.
Because we're strings all the way, this also just works. And dealing with strings is actually, I think, pretty idiomatic in some senses. In Swift, for instance, there's this generate your boilerplate macro that takes a a string of things we want to substitute into, and this is how you would generate like all of these types.
This is interesting. But again, if you had structs as values, and you could construct them through other means, right? Then you would need reflection from this. Like, you wouldn't need reflection because then you could just create the structs within the language. And then here with the naming as well, like if you could have a way to construct identifier names, but like dynamically, that'd be really interesting. Really interesting. I mean, dynamically, like at compile time, at runtime, probably would be more hassle than worth it, just because like even for like performance reasons. But this would be cool if you could construct identifier names dynamically. And like, how'd you do that? I don't know, but like if you can find a way to do it that once again doesn't rely on macros or string stuff like we have here, it'd be pretty cool, wouldn't it? Oh, so what's this dollar sign? I thought Swift didn't use dollar sign. Oh, I'm guessing it's exclusive to this macro then. Assuming this is actually a macro, it must be, right?
Now, on the positive side, there's a particularly cool Swift macro called predicate in the standard library, where, you know, of course in Swift you can write an arbitrary predicate to check things about a type. That's not particularly hard. But what if you want to do more interesting things with this resulting predicate? For instance, like I want to serialize this somewhere. I want to store this in JSON. I want to pass this to another application that's doing some kind of research. How do you write your predicate in a way that's nice and readable in code, but then also make it serializable? And what Swift does in this case, you can take advantage of the fact that this lambda will be completely type checked by the Swift compiler. We can validate that, like, yeah, t.price and t.symbol exists. These checks are valid. And instead, it's going to generate something that looks like this. And this is a completely different structure that it just read through the lambda and produced something that is actually serializable, which is kind of cool. This is something that's possible. Rust is very different, on the other hand. It's a very different philosophy around expression macros, which is basically you can do whatever you want. And so the Swift approach to stringify looks kind of like this. We declare a pattern that we're matching our input tokens against, and we inject tokens that are the result of the pattern. Now, this isn't quite entirely token-based in the sense that when I'm matching an expression E, the resulting expression is that whole like syntax node that is that expression. So the kind of issues that a few people have mentioned earlier with like parenthesization and precedence, these don't come up here, right? This is the full expression. And doing something implies where I really, for some reason, insisted on having expression arrow expression. That's also very easy to do in Rust. I just write that pattern that I'm matching expression arrow expression, and I inject the correct code. And this.
Yeah. I will say that it's cool for like this is a cool idea for like creating a programming language. You could say, but no.
This just works. For instance, I can have an implies macro, and if A is less than or equal to 10, that just evaluates as true, and I don't panic. And now this approach to actually writing DSLs is, I think, pretty idiomatic in Rust. People do this a lot. And so, for instance, here's kind of a macro, and what this macro is doing is it's implementing support for multiplication from one pair of types to another output. And you can see that the invocation of the macro, I'm adding these parentheses in this arrow, which makes it easy to see in the invocation like how these things are grouped. Right? It's like easy to see for the reader that like, okay, this is U8 times non-zero U8, and that produces a U16. And you could, of course, write this macro to just take 4 types. But like having this extra DSL niceties, it just makes it a little bit easier to read. Even though these are the only 3 invocations of this macro in this code base, and they're all right here, it's just a little bit nice and extra to add. Of course, you're not limited by one pattern. Macros in Rust can have multiple different patterns. Vec is probably the one that people are most familiar with, which has 2 different uses, and it even has a repetition primitive. So a lot of these things are kind of nice to produce.
So weird how Vec. Also, yeah, macros can be overloaded. Like for a language that doesn't allow overloading, for some reason macros can be. Like I feel like a lot of Rust's flaws, it just gets around them with macros, and it's so stupid. It's actually so stupid. Like, what? Like, is this helping you write cleaner code, or is it just filling in the gaps? Like, so why does Vec even create a Vec and then like push into it one by one, as opposed to just? I mean, maybe the implementation he showed is incorrect, but like, can you not just construct the vector with all its elements? Hey.
And so, for instance, like I can produce like a dict literal, like in Python. This is not in the Rust standard library, but I can write this. But if I really wanted to go full Python, because Python, of course, uses colons, I can't really do anything. Because Rust expressions can actually have a colon in them, and so how is the compiler going to know how to parse this? But Rust expressions can't have a fat arrow, so you can't really do anything. But it's pretty easy to produce arbitrary DSL.
So there are limitations anyway. You can't have a colon. It's like so arbitrary as well. And I feel like a lot of Rust philosophy, by the way, is like, like, we won't limit this. Like, we're just going to design it this way, and, if it happens to be flexible in some ways and inflexible in others, then it wasn't really intended anyway, so we're going to leave it. But the issue then is that people will abuse it. For example, like the fact that Rust macros, I've shown this example before, but like, I literally cannot believe it. That you can do this. Let's just have function main, right? And the print line, hello, right? Pretty simple, pretty unsuspecting, whatever. Now, for whatever reason, I can just replace these brackets. Also, by the way, I do need a semicolon at the end of these lines for some reason, because it's a single expression, so it's fine. But it's like, well, that's completely inconsistent. Like what? Like I can use curly brackets. Okay. Guess what? I can also use square brackets. Like what? Why? Literally why? Like it, and like the answer is because restricting it would take effort. So like let's just not restrict it and let's just have it be what it is. But it's like what? Like why isn't the bracket type specified in the macro definition? Literally why would I want? I don't know where the fuck that came from. Why would I want this to be something that people can just arbitrarily choose? It doesn't make sense. It literally doesn't make sense. It's just a lazy oversight. And I say lazy oversight because I'm sure they were aware of it. They just ignored it. And it's so annoying. It's like one of the many things in Rust, like philosophy-wise, it just completely doesn't make sense to me. Yeah, man. Like, let's say we have Jimmy, who says, well, I want my vectors to be C++ style. So I'm going to create a vector. I'm going to call it vec, because why not? And then that'll be equals to vec with an exclamation mark, just a macro instead. Like vec macro as well. It's just such a bad name. And then, I'm going to give it a C++ array style with 1, 2, 3, 4. I don't even need a semicolon, by the way. Fun fact. And then I'm just going to go ahead and print line. I'm going to use square brackets because I'm a jackass, and I'm going to put it there. Except I have to put it in things. So I'll put it like this, I guess. And let's run that. Again, don't need a semicolon. Okay, I guess I do need a semicolon now, even though in other cases you don't for the curly braces, but okay. It doesn't implement forward display, so I have to use pretty printing instead. Hashtag. Is it like this? No, what did I expect? Expected that in the format string. It's like that. Arbitrary syntax, by the way, but whatever. Right, so that prints. Now, for some reason, like I swear you can usually just not put a semicolon here because it'll insert it automatically. But I guess here, now it does. I don't understand that either. Let me try it like this. That should be an error, yes. But does it work like this? Does it work like this? That works. So like I need a semicolon here, but I don't here. I guess because this is a let statement, so like that's the whole thing. It's like, what? Make it make sense. Make it make sense. It's so dumb. Like why can't it just be let vec equal vec capital colon new, 1, 2, 3, 4, or like vec like this, like a function, with like a constructor, but because they're capitalized, you can't confuse it for a function call. Like just it's so weird, and I really think it's gonna catch up to Rust at some point. There's this way of implementing a language. I think it's going to come back to bite it in the ass, and I really hope it does, because I will feel vindicated.
One of the most interesting ones that I'm personally familiar with is from the Tokyo library, and this is like the Rust asynchronous framework that a lot of people use.
What it does is it makes Rust so weird to work with. Like whenever I want to do something in Rust, like okay, I'm going to try web dev in Rust, I'm going to try game dev in Rust, I'm going to try, I don't know, some printing in Rust. Like suddenly I have all these macros that I need to learn, and it's like I didn't choose Rust to learn all these different macro systems. I chose Rust to learn Rust. So why can't Rust just work like Rust?
And so select here is a macro that chooses one of a bunch of concurrent branches, and it picks the one that's available. And the syntax in the select invocation, like this is not valid Rust syntax, like it's completely meaningless, but it's a really expressive way of writing the code you want to write, because you pick stream1.next if that actually evaluates to that particular pattern. If there is some value, then I go and I run that handler, and this is a nice way of doing things. Now Rust actually has two macro systems that you can use for expressions. You can use the declarative ones, which I showed before, where you show the pattern or the example by which we're parsing these tokens, and there's the procedural macros. And so the original debug implementation that I showed, that's a procedural macro, and in the procedural world, it's just tokens in, tokens out. And so it's up to you to figure out how to parse them, like how to make sense of any of these tokens. And so in order to parse this, there's a library for that. So I can write a type. In this case, I'm looking for an expression, then the fat arrow token, then another expression. I have to implement how this thing is parsed from an arbitrary token stream, and then I go ahead and I write my function that first parses that macro into my type, and then it ultimately injects returns the tokens that I need to inject. And I end up with something that looks the same, perhaps unsurprisingly, since I'm doing the same thing. It may maybe be more obvious if I actually use the same variable names in both cases. And so, what do we think about these two different models?
I mean, this is obviously a lot more, easy. It's just syntactic sugar for this. I mean, it's the same thing. This one just operates on a token stream directly. Yeah, because this uses pattern matching, right? Which is quite convenient. And this looks similar to what he was trying to do with the C++ version, right?
I mean, it's pretty easy to look at the one on the left and be like, well, that is a lot less code. It is straight to the point. The pattern that I'm parsing is right there. It's very clearly visible. But the one on the right has a lot of advantages too. In particular, because this is just a normal Rust function, I can do whatever I need to do in it. I can do arbitrarily complicated things to build up the tokens that I need to inject. It has a lot more functionality. It's a lot more flexible. So it's not necessarily particularly obvious that the declarative approach is the way to go. And there's a lot of reasons to really prefer to have that procedural thing as at least an option available to us. And so one cool example of something that you can do procedurally but you can't do declaratively is in the SQLX library, there's this query macro, because of course you might want to query a database. But if you look at what's going on in this example, it's like I'm running this query, I'm getting my ID, name, and email from all my users, and I'm just printing them. But I'm printing them by name, right? I'm not looking up the fields by string. These are actually identifiers. And this works because rows is actually a vec of record, which has an I64 field for the ID and string fields for the other two. So how does this?
Obviously. I mean, if you know what rows is, then fair enough. Although I don't like how the type inference doesn't require you to give the type. I think you should put your type here. It's literally practice for C++ programmers not to abuse auto. I don't know why Rust programmers have just abandoned that largely. To the point where fucking like the compiler will even sometimes suggest you to just use type inference. It's like, no, I know what the type is meant to be, and it makes the code easier to read if I can see what the type is when I need to see what the type is. That's supposed to have to like look further down in the code or look for some other definition, like see what SQL X query happens to return. Obviously, if you have like an LSP, it makes things easier, but I don't like relying on that. I think if you're going to do that, you can make a much more interesting language anyway. That is like IDE assisted, an IDE assisted language. But if you're not going to go that far, then just don't. Why is that even a macro? Why is query a macro? Because like it's just a string input.
How does this actually work? It's not like that the library is just guessing that like, oh, ID, that's probably an int, and name and email, that's probably a string, that's good enough. This macro is actually going to, at compile time, connect to your database or whatever approximates your database. It doesn't have to be the real thing. It's going to validate your query, and it's going to look up all the types for you.
Right, because I guess Rust has no way to do compile time stuff without macros. It's annoying.
For you and figure out what you need. And the result of that is if I make a typo, if I look up ID2, that's actually a compile error because there's no ID2. And so there's a lot of potential things you can do in a world where if you're not just limited to pure token substitution and token pasting, right? Like having a full function available to you just lets you.
Yeah, I just understood what it does. Don't like that. Like, what's wrong with having strings? Honestly. Because, like, it's just clear that it's strings. Otherwise, like, there's confusion, like, where's ID coming from? Where's this coming from? Oh, the macro generates a struct. Oh, and then puts the fields in. Oh, and I guess at compile time, and, like, it queries a thing, like, literally at compile time, and, like, it creates a struct from it. It's like, oh, yeah, of course. Like, what? Like, what? Like, at that point, what? Just don't. Just write what's actually happening instead of like hiding all these things away. Because like, I get like it's not even like an abstraction feature. It's just an indirection feature. Abstraction will like make things, easier to comprehend, whatever. Like to keep in your head. But like this kind of stuff is just indirection. Like the power of abstraction comes from when a language has what's the word? Consistent syntax, and you're able to create abstractions from that syntax that are intuitive. And you're like, so like even though you're looking at an abstraction, because it's built in the language and looks like normal language code, you're like, yeah, okay, yeah. So like that's that. Yeah, that makes sense. Here, it's just like, it's kind of sidestepping your expectations, what you would expect the thing to do. So then you have to learn this new thing. And then like, it's not really an abstraction anymore. It's more just like a language extension, kind of. And like, if I wanted language extensions, I would add it to the language, I feel. Like Rust isn't like an old language. Like it does get updates and stuff.
You do more things for you and figure out what you need. And the result of that is if I make a typo, if I look up ID2, that's actually a compile error because there's no ID2. And so there's a lot of potential things you can do in a world where if you're not just limited to pure token substitution and token pasting, right? Like having a full function available to you just lets you do more things. And so if we compare these three, they have very different approaches to solving the problem of how do I parse the input to my macro. In Swift, we just parse expressions. So Swift macros look and feel like Swift functions. And we solve the parsing problem by like, okay, they're just functions. We're just going to reuse the same machinery there. For declarative macros, you actually provide the pattern or patterns that the compiler needs to match. And then for procedural, it's just tokens all the way down. You're on your own. In the Swift world, in the same way that we saw earlier, we produce on the output side a string or AST. In the Rust world, we're just producing tokens. In all these cases, again, we're just doing weight checking. There's no actual checking of any of the syntax we're producing until injection actually occurs. And then the model of what you can actually do is very different. In Swift macros and procedural macros, the implementation, these are just regular Swift and Rust functions. And so you can do all of what's available to you in Swift and Rust code. Like however you want to produce your tokens, it's available to you. In declarative macros, it's just substitution or repetition. So in this sense, it's a lot closer to being a regular C macro.
Let me have a look at this real quick. How do you not know this? Template 4. Am I not on a UK keyboard? What Shift Alt hashtag gives you that? Why is it there? So today I learned that Linux has a different map for UK keyboards. That's kind of funny. That's actually ridiculous. What the hell?
And you know that's very derogatory because you know I don't mean like they're like what C macros could be if C macros were awesome, but they're still very limited in that sense. Like you have your pattern, and you can do stuff with that pattern. We have these nice substitution repetition primitives. They have scoping. Things are grouped by AST nodes. So you don't have to worry about parenthesization as much. They're hygienic, right? So they have all these things that C macros don't have, but they're still limited. Right? They're still not full functions. So the question is like, okay, so like that's what macros look like in other languages. Like what should macros in C++ look like? And this is one where, like, to be honest, like I don't really have much of an answer, but we can walk through some examples of things that we might want to support in macros to kind of learn about what they could look like. And the easiest one to start with is, I think, forwarding. Like this is a macro that I think a lot of people have in a lot of code bases. Some people probably have multiple different versions of it in code bases because it's a very easy macro. And some people have a macro like this to avoid instantiating std forward so things compile faster. But personally, I like it because forwarding is a unary operation, and being able to have a forwarding macro makes the code look like it's unary. But a call to std forward is a binary operation, right? It takes a type and an expression, even though the type is derivable from the expression almost all the time. So it's kind of it has the wrong arity, and so I like the macro approach.
I'd rather just add an improved std forward.
And so in a C++ macro world, like how might forwarding work? Well, we could go all types all the way, right? Like we have a type on the way in, sort of like a function template, and on the way out, we have an expression. And we just say like, okay, this macro gives you that expression. We're just like all types all the way. That's one approach. We could go back to token sequences and have this macro return the tokens that we need. That could work in this case. Or we can just be all tokens all the time, which in this case is very simple because we don't have to do any parsing at all because we're just consuming the entire input. So like, what can we learn from forwarding? I don't think we can learn anything from forwarding. Any option basically works fine. So let's talk about assert. And like, yeah, contracts and whatever, but how do you write assert as a macro. Like it's not that big of a difference. Like we're going from forward, which takes one argument, to assert, which takes two. But it turns out this is an enormous increase in complexity because it turns out that just counting expressions is hard in C++. Like how do we make sense of this, right? Because if you look at something like this, we have this problem of like how many expressions am I passing to call? And so if call was a C macro, the answer is just 2. We're just unconditionally passing 2 expressions. But if this is regular C++ code, the answer is it depends. Like this could be 1 expression, or this could be 2 expressions. It depends on what the types of all of these things are. And if we're going to have like a new and better macro system, like it better parse this correctly based on what the code actually is. Like this better be either 1 or 2 arguments based on like what the expressions actually are, because like otherwise like what are we even doing? Like what's the point? And so like again in the typed world, this is easy. Like I have 2 expressions, so I'm just going to declare my assert macro to take 2 expressions, and it doesn't super matter what the if I'm actually returning an expression or returning a token sequence, that works. But in the token sequence all the way in, like, okay, now we suddenly need like a parsing library. We need some way to make some sense of these tokens. So we need like this whole set of abstractions for like how to pull out expressions and what kinds of things are we allowed to pull out. And maybe someone like Zach will come along and give us a library to give us some sensible syntax for parsing expression, comma expression. But this is something that we're going to need to, we would have to solve. Alternatively, we allow macros to be defined somehow so that the parameters they take are actually kinds of grammar.
I saw the operator overloading there. Again, same people who swear that C++ operator overloading is bad still like Rust macros. It's like, have we learned anything, or are we just kind of shifting the, like it's a wolf in sheep's clothing, except it's not even in sheep's clothing. It's just people just ignoring it. I don't know.
And we parse things that way. Like I don't know what this ends up looking like. Maybe this works. But if we look at a completely different example, so for instance, there's this library boost lambda 2, and it uses a lot of macros to define just a bunch of function objects. Right? This is pure like we're defining a bunch of binary function objects with these operators. We're defining a bunch of unary function objects with these operators. So what might that macro look like? Well, we could do something like, okay, we're just going to define a different macro for every shape. Or we could get really cute and we could say, okay, like well, what I really want to do is I want to define the macro in such a way that I'm passing an expression that looks like the use of it, right? Like maybe that seems pretty nice, and that would be a nice way to differentiate between star x for dereference and x star y for multiplication, which otherwise would both just use star. So with a type-based model, you can't really do anything except for pass strings. So the only option is pass strings, because none of these are like valid expressions or anything like that that's parsable. And that seems pretty underwhelming. I don't think we'd really want to resort to something like that. With the token sequence all the way in approach, it's like, okay, but like now I have to like do all this parsing, and this is kind of complicated. It gets a little bit nicer maybe if we like go all in on the like actually having types and differentiating that way. But this is what that approach looks like in Rust. And like on the one hand, like, okay, this isn't so bad. It's pretty nice to produce all of these different patterns. But on the other hand, this also gets pretty complicated really fast. And it's easy to suddenly have these patterns be a lot harder for users to read as they get more complicated. But of course, like with assert, like we don't just want to have like a binary assert that takes 2 expressions. We probably also want to add more context to this, right? We want to print some kind of string that we want to format to provide more information, so that when an assertion fails, you have more knowledge about what's going on other than just the expressions. And this is obviously very easy to do in a type-based model. You just write a variadic template. But again, this becomes much harder in a token sequence model. But on the other side, like, I have on an occasion or two complained about how verbose lambdas are in C++, especially for the easy cases, where on the one hand it's actually super nice that lambdas have the flexibility that they have, because you can write arbitrary complicated things, and you can write very long lambdas that do whatever you want and control the capture and everything. But what we pay for that is that in the simple case where like I just want to like sort my points by x, for instance, that's a very verbose thing to write in lambdas, and it would be nice if I can just write something like very terse. And this obviously does not work in any kind of type-based macro model, But if I have token sequences, yeah, sure, like I just like walk the token sequence, I look for identifiers, I pick out the largest one, I determine the arity from that, then I produce my parameters based on that arity, and then I inject the body, which was actually like the argument into the lambda. So that's, I mean, that seems pretty nice and easy to do. I don't know. So this of course begs the question of like, okay, like what?
But again, or C++ could just implement easier lambdas. Thing is though, right? You can opt into these in a way that's almost like opting into language features, right? Whereas when C++, I mean, you still opt into C++ features, but like on a more fundamental level, like C++ can't add tensor lambdas, and it can't add, sorry, it can't add like, I don't know, question mark early return. Like it can't do that without it making it a core language feature. You know, like pattern matching, whatever. Like these are things that have to be core language features, unlike, you know, library functions, which can be added when you want them, and included when you want them. But even so, like if tensor lambdas are so important, C++ could just add that. And it's like, if it doesn't, there are probably good reasons for it. And if it doesn't, you using some other, like it's almost like if I created a macro right now in C that defined fn as auto. So then I can define my functions as fn and then have my trailing return type, right? Like that's something that I was going to do in my game engine because it's not libraries, like I can do whatever the fuck I want. But I was like, you know what? Even though this is like a personal project, I still want people to be able to read this code. And if I limit doing stuff like that and just keep it as like, you know, pretty expected C++, within the standard, then people will have an easier time reading it, you know? So then I like, even though, so then what you do is you end up even writing like code that's seen as verbose in C++, simply so it remains understandable. And that's really interesting. And like, I'll only ever use macros and some very rare instances if it really makes things convenient. But again, only because C++ lacks that feature anyway. And I wish it had it, and it might even be coming in the future type thing. So, yeah. Point in case, you shouldn't need macros. You shouldn't need macros. What else was there? Something else about that. I can't remember.
Which way should we potentially think about going? Do we go with the type-based approach for the macro side? Do we go to the token-based approach? And really, this I think undersells the difficulty because we really have like all these paths going all over the place. Some of them kind of like go out into space. Like some of these things are really shiny. Like, and I don't really know. It's a pretty difficult problem. But I think it's one that would be pretty cool to have a good solution for. Because it turns out like people still use C macros for a lot of things because C macros are so useful, and it'd be nice to replace that with better technology that's a lot more useful to solve problems.
We went from reflection to now saying we should improve C macros. I think there's a reason. Well, I don't think there is a reason that C macros have not been touched since their inception. In C++. I mean, C99 and whatever had like other things, but. To my knowledge, C++ itself has not done anything with C macros beyond what it needs to remain backwards compatible with C to an extent. It's like, so, and the reason for that is because Bjarne, and I assume others, don't want people using macros. They want to find non-macro solutions to these, and I find that nice. Because the day that C++ just goes all in on C macros is the day that the language kind of just stops. Like, I think it would be terrible for the language. Because then code just goes from like kind of unreadable to like, okay, it's getting better with modern features, now it's more readable, to just like, I have no idea what's going on here. There's like macro magic everywhere, macro bullshit everywhere. It's not the path we want to go down.
Yeah.
At least on the input side, is it clear that we have to choose, or that we kind of say, I need something where it's beneficial that I have a really parse thing because I need that power, or I have a thing where the token sequence is better and then I do it, I consume a token sequence.
So on the one hand, I can look at like, okay, well, if I just took a token sequence as input, that is obviously the most general solution that can obviously handle all possible inputs. But is it actually possible to like, how complicated are these things going to be to implement? How hard to understand? The type-based one is, I think, a lot easier to implement. And by implement, I mean both in the sense of like in the compiler and the user writing these things, because I think we've all written functions and function templates, so writing a type-based macro is, I think, pretty easy to understand. And so both have a lot of benefits, and both have a lot of cost and limitation. And I
No. Well. The cats are meant to be in the counters, I've been told. So okay, fuck me. So whenever they go in the counters, I gently nudge them off. As in, they jump down themselves. I don't like push them off.
don't know. I think it's an important thing to think about, but I don't have any more insight than that into this problem. Yeah.
For token sequences, because like as illustrated by the existence of type thing, right? Like you need access to like the compiler symbol table to actually tell you, like you don't know if that's a template or two less than expression, right?
Right.
Less
So like,
than greater than expression, unless you know.
yeah, and so like that's the thing. So like if we do do like a pure token-based input, we need to parse those things and we need to pull out an expression, and that parsing had better be correct. Like it better be contextual and understand what these things to parse them correctly. Because if it can't, then like this is a bad solution. And so like how do we actually make that work?
Wouldn't it be better off to have access to AST because that tells you how it was parsed?
Yeah, maybe. But then you also run into the problem that like someone else mentioned earlier is that like, well, not every compiler, not every C++ implementation even has an AST. Like, how do you standardize on this? What does the shape end up looking like? So like, to the extent that something is standardizable, it would have to be like very high level. Like something like expression is viable, but like going something like narrower than there, like binary operator, a cast expression, assignment expression, like I don't. Like how precise do you want to be in the grammar? It becomes a much harder problem.
Well, for your example, you would have to know like whether it's a template ID or not.
Possibly. Yeah, I don't know. Yeah.
So Meta already does this though, right? Because we can already query elements of the AST. We don't call them that, but we can query things about them, their names and elements like that. And then define aggregate already goes the other way, right? We could inject things into the AST already programmatically without using tokens. So in the small, we already are doing this in C++ 26.
Kind of, but none of these things are like AST. Like we never really talk about like specific elements of syntax.
These are features
right?
that aren't being addressed.
Say it that way, but point being, we are already doing this in the small without dealing with token streams.
Yeah, kind of, yeah. Yep.
There
so
are a lot of compile time parsing libraries that can do things like the SQL examples that you saw. Both of the Rust macros can be implemented with compile time in C++ with compile time parsing. So we can already create like an intermediate representation of some costume syntax and then use it to generate something at compile time with a callable object. The generation part is what is missing because we're using templates to generate the reflection and all the upcoming features.
I love how you get like a range of
So
accents.
this is, I think, where
It's almost like people discussing like World War negotiations. Because C++, you know, is used by the world at a global scale.
There are also ways to get an intermediate representation of the C++ code, but it's more tricky. When it comes to going to token stream, the main issues that I see, because let's say I want to reflect something about the body of a function. If I get the token stream and I want to parse it, then I'm like parsing C++ at compile time from a token stream is infeasible in my opinion.
But that's not. But like the compiler is already parsing C++ from a token stream, right?
Yeah.
So we do have the existence proof that it's possible, it's more the question of like how does it understand the right context? How do these things pass together? How is it possible to understand what code you're writing?
Did all compilers even use tokens? Like the old single pass compilers way back in the day. I remember hearing at some point that they didn't even do that. They just straight up read the strings in buffers or something like that, which is interesting. Probably should just use tokens because that's kind of a better, more robust model, but just worth pointing out.
So, it's certainly not impossible, but like how do you make it work such that it's easy to use? For
parser needs the type information that's hard in C++.
Right. I mean, if only we had a parsable language, this would solve a lot of problems. But I think that ship has sailed a few decades ago.
And one more thing, let's say we, instead of implementing it ourselves at compile time, we have a hook to the parser of the language of the compiler. Then we need to have consistent return result from the parser across all the compilers. So we will need to have standard intermediate representation anyway across all the compilers.
That's what you said, yeah.
Yeah, so it's a tough nut to crack, for sure.
I mean, I think it also goes to, you say Rust-derived macros are token to token, and technically true, but everyone who implements a Rust macro uses the proc2 library, which parses the tokens into an AST and then lets you output an AST. And
well, you output tokens though.
No, you can output the proc2 library. There's a thing to say, great, take this AST and go to a token stream for me. And so everyone almost everyone operates entirely in the AST to AST space, and just has proc2 tokens to AST, AST to tokens before and after.
So then it's like you're literally creating an AST from tokens from the language, and then that can be standard. Honestly, it's a smart solution, but it's but at what point do we just create a new programming language? Honestly, generally, at what point are you just creating a sub language within the language? And then at what point do you go hold on, maybe we can just create a new language that just accommodates these features? That's what I mean. Because what macros do is, like I said, it effectively adds language features. If you add those language features, you don't need the macros. So it's just a question of how far will a language go. And I think that's why the best thing to do is to create a language without macros, and whenever there are limitations, add those through features. That is what C++ has done for the past few decades, and it is what I believe has kept it as alive as it is. And why the modern features actually feel good to use, they don't, a lot of people say, don't use modern C++ features, they're bad or whatever. It's not true. It's really not true. The bad C++ features, that's people in 2026 looking at C++ 11 or prior code, Back when the language was in a much worse state. But even then, the features that were added at the time were still really, really useful for the developers who are using the language. It's just in retrospect, you say, oh, okay, that was a mistake. So now in our 2026, you can choose features that are good for you, right? That are actually good, and then you have a much nicer language than before. And C++ has never had to rely on macros for that, because it adds features. Yes, there are issues with adding loads and loads of features on top of each other, but it still has been good for the language. The language is better off now than it has been before without adding these new features. Even though it makes things mostly syntax. It makes the syntax very problematic, and it creates issues with syntax, like how you need to use caret colon to access S standard meta. I mean, you don't have to, but that's an example of some kind of syntax that has spawned from C++ having limited syntax, but it's expected from an evolving language, right? Rust just won't have that, because Rust is going to probably end up relying too heavily on macros. Already using leptos is absolute hell, because it's just macro hell. I don't understand what I'm writing. I'm literally learning a new language to the point where it's dude, just just make like your own Leptos language, and it would probably be better. It would just be a lot more effort. But like, would it even be that much more effort? Like the amount of time they spent tweaking like the Rust macros to make it work for Leptos. Like, really the main benefit is that you can use Rust tooling, I guess. Like, that's it. But like then, and also because people use Rust, it means you can also sell your library more, better, because people are like, oh yeah, I can use a library in Rust. Awesome. I use Rust. I can use it. But yeah, it's just not. It's not good, man. It's not good. I've said it like 10 times in this video. I'll say it more.
And that's what you sort of hear here is people are like, I don't want to parse C++ from tokens. I want a library to do it. But boy, oh boy, I do not want to embed like the entirety of Clang into every thing I have just to use token generation.
Okay, so I took you all.
What are some of these comments? The crowd.
All kind of on an interesting journey today, I think. So I started out by throwing out that I think we should strive for this guideline, that no raw code. We should try to recognize when we're writing incidental data to our main application and try to automate away the generation of that. But of course, we don't have all the language facilities that we need to do that. And then, even though this is C++ now, you're all here, you want to learn about what's on the cutting edge of C++. And then what I did instead is I spent all this time talking about C, and then I showed you a bunch of Swift and Rust code, which is notably not C++. And hopefully, like, I think you agree that was a worthwhile journey to take, because I think it's interesting to look at what other languages that are fairly similar to us in a lot of ways, the kind of choices that they made, and what we can learn from them. And I think it's through taking this journey that I think I can make kind of my contribution to how to answer this question, which is, personally right now, I think that this token sequence approach is the most viable path for C++. But ultimately, regardless of the specific details of a lot of what we decide on, like I think the fundamental point is that however source code generation ends up looking, it must allow all of C++. Like, I don't want another kind of discovered sublanguage with its own algorithms, with its own domain libraries and stuff like that. Like, I want source code generation to look like C++. In the same way that when I look at these.
Huh? What is this standard, bro? This came out of nowhere. This says C for C2Y, where I assume C20Y is like a year thing. Surely this means it'll come to C++ too, right? If bool x equals true, then you can use x here. I mean, it's a bit precarious though. It's like, Hold on, can you use... I might need to revisit the pattern matching, actually. For, hold on, C++ pattern matching, like the official paper. Is it even standard yet? Is pattern matching standard yet? I'm not sure it is. I'm looking for the Herb Setzer one, this one, with is and as. 224, revision 3. For some reason, the only, like a lot of the papers that have a latest revision button are the ones that are the latest revisions. That's really annoying, but anywho. The thing is, I can't remember if is and as can also define, because then that can be used in if statements. That'd be really cool. Like is int I like defines it, right? I forget if you can use that outside of pattern matching. You can. No, you can't. That's X. But this works. I'm looking. IDK the status of C++ pattern matching, but I really like Herb's proposal for the is operator, and that would do like if wait, it's like X is true. That's like the structure, right? Like, can I say X is true? Is that a thing I can do? What are all the cases here? Bool X equals true. So we're defining X, right? Can you do values? There is null pointer. C is null pointer. Outside pattern matching. X is 3. Can I define something like that? Bool X equals true X. I mean, this isn't really a good example, is it? Like, you wouldn't do it like this. You do it more with, like, expected or something. Yeah, so, like, maybe foo is int foo. It's like standard, expected, int equals say int void, whatever, maybe foo equals in like standard print line foo. Yeah, Monocraft looks awesome actually, by the way. It's like Minecraft, but it has ligatures, which is the main thing I like about it. Right.
These other languages, like source code generation in Rust looks like Rust, except for declarative macros, and source code generation in Swift looks like Swift. And that makes these things a lot easier to learn how to do. Because ultimately, right now, reflection is only half the story. And even though we don't really have an answer yet for what the other half ends up looking like, I'm hoping that this at least gives us.
Hold on. OT equals object is A, my class.class T. That's an objective C.
Some more information to think about what it might look like in the future. Thank you.
Questions?
Yep.
I understand what you're going with. I think I agree with this, but I want to play devil's advocate and challenge it on one point.
Sure.
If I were to, let's say, okay, I don't have any of this now, I'll solve it by, a two-step, like a preprocessor, two-step compiler kind of. I'll write a script that goes over, let's say, reads my struct, generates, for parameter, printer, serializer. I would write that script in C++. C++ is a terrible language for writing compilers. So do we really want all of C++, if I don't want to write like extended C++ to C++ compiler in C++. Do I want to write that thing in C++?
It's a funny question. C++ is a terrible language for writing compilers. Pattern matching is coming, which will make things a lot easier. You don't need to rely on variant and the visitor pattern just to have tagged unions functionality. You'll be able to pattern match instead, which will be a lot easier. But it's not to say that we will get tagged unions. We won't, at least not for now. But still, the pattern matching will just make things a lot easier in terms of matching them, right? Matching against them, and how it's having exhaustion. I guess with like a syntax tree as well. Is it that bad? I don't know. Like here, like the names get very long, but if you can also just not use those names. You can use aliases. Like I make although I'm not using macros in my, well, at least I'm not doing stuff like defining fn as auto in my game project, my C++ game project. What I am doing is using type aliases like U32 for standard uint32t and F32 for for float, with a later when it's supported standard float 32t, with a capital F, capital U, because I want those as well. For expected, I'm using results, so standard expected, V, and then string would be my error type for now until I get reflection. Then I probably have to be a meta info, and then results is the alias for that with a capital R, and stuff like that, right? So like you can create your own aliases. Yes, it will make your code base a bit less accessible, just because people want to immediately understand what the types are. Obviously, like U32, F32, like those are fine to understand. But like stuff like results, for instance. But like even then, results also encodes the information, so that's not a big issue. Like it encodes the error type as well. So it's just result T as opposed to result TE. So that helps. But like it's still predictable. Like either way, like you can look at the definition of result and see, okay, result is just this, and you can find that fairly easily, and the same way that you would, I don't know, look for like a class definition or like a function definition to see what it does. Although the name should also encode it anyway. Like if I store results in a C++ code base as a custom type, I would just assume it's like a wrapper for expected, or like some custom expected implementation, whatever. And then I can verify that. But like generally speaking, I know the gist, right? Like I'm not calling it fucking my Kojo wrapper type. Like no, I'm calling it results, which is fairly understood. So if like optional, if I call it option, no one's gonna like explode on the spot because what do you mean option? What could that possibly mean? Like yeah, it's optional. Who would have thought? Or like string for a standard string. So and it means that if you want to swap out the type, you can do that, but you probably don't want to do that anyway. But anyway, just some thoughts there.
Yeah, so I do think we do. And so I think, going back historically a bit, one of the main benefits of class templates over macros is that with macros, you have this problem of, okay, like I can have a macro that generates my type, but I need this like pre-step of like, I have a macro to declare my type and then I have a macro to use my type, right? And so one of the things that class templates allow is that like, I'm just like somewhere in code in a function template, I need a vector of this type, I just go like vector T, right? So I don't have like, how do I like go out and like inject my type somewhere? Like there's no real place where like an external generator could run and produce the code that I need. Whereas if within the C++ compilation process, because like it is very complicated, I can produce types on the fly as I go. And reflection makes it a lot easier to produce a lot more interesting types on the fly. Like I want these random types that I'm producing on the fly to be formatable. And so where in this process can I make them formatable if not within C++? And so there's certainly like a lot of places where sure, like an external code generator could solve the problem just fine. But there's a lot of places like that where I need kind of this core functionality that if it's not within the language, it just has a lot more like friction. And
no, I was advocating for external code generators as a non-optimal solution. What I was saying was, if I find it a lot easier to use a different language for external code generation because it has much better string handling facilities, wouldn't I run into exact same problem trying to use C++ to require C++, and wouldn't I want for the same more powerful string handling facilities?
Yeah. Well, so I mean, this is part of why, I don't think that strings are the right answer here because I think strings have like their own set of problems. But like I think it's possible to add the facilities that we need to make like sequences of tokens easy enough to handle. These are broadly useful things. And
that you see I mean, because it doesn't seem to me like there's any fundamental problem with C++ handling strings well. It's just
some of the most basic operations for strings. And so like I'm not going to talk about UTF because I don't know anything about Unicode and I don't want to know anything about Unicode. But when we talk like really basic like string manipulation stuff, is like how do I split a string and how do I join a string?
Correct.
Like
okay, whatever. Right, now I understand this comment. I read it before, but I didn't actually understand it. But now, for some reason, it's just clicked. Can each version of C++ make a version profile and implement a few features based on that? Maybe this will make the implementation of compilers easier over time. I'm totally fine with that some features are only available to new C++ projects. I think the version profile is... Actually, let me just check out inside. C++ version profiles. Right, yeah, so it's like restrictions on the language in a way that lets you break backwards compatibility in a way. So like I can say, okay, let me use this language, but restrict this stuff. And it's kind of like compiler defined in a way. I mean, not compiler, like, I mean, it's like having compiler restrictions, except like it's standard, right? Kind of. What's even happening with C++ profiles? I do want that actually, but anyway, something along those lines. I don't know if that's what he's even talking about though in the comment. Wayne, whatever. I mean, I don't know if this is true, like if that's the reason that C++ hasn't done it. Although I did actually put a thing here, didn't I? I did a search here. Fuck me, Google search, man. Let me just ask Claude. How come C++ hasn't ever focused on really improving C macros? Rust has really powerful macros, for instance, but C++ doesn't seem interested. Oh, so that's where that comes from, the 2 token split. Yeah, so like there is the perfect world argument, right? Like, you know, ideally we wouldn't need them, but we do need them. But I don't like that. I don't like that because then that's an excuse for laziness. Excuse for ignorance, what does that mean? This expert gave out Turing complete compile system. Yeah, but I mean, what is the cause for the cultural stance that macros should be replaced? I wonder what the decision was behind Rust macros being overloadable. Like, was it just like a necessity? Ay, ay, ay. Why was main never used? What the hell? What caused that error? Horrible for compiler errors. Why? Constrained generics. Does it even compile? Let me just double check that before I post this. To be funny. Typo. Why do I get this error? I was about to press execute. Compile and execute are different. What the hell? Cool. Text substitution, break scoping, type safety. Yeah, but that's for text substitution. Debugging tooling pain was because it's invisible to the type system. Okay, but it could be. Real bugs, I mean, it doesn't have to be. Real bugs from lack of hygiene. Yeah, that's also can be that can be fixed. Strawstrip. He said explicitly that the preprocessor is a language outside the language and violates the abstraction principle C++ is built on. So for very early on, prefer const enum inline over dfinal invested. Okay. Okay, but why doesn't C++? Okay, but is there a resistance to implementing something akin to Rust macros? An equivalent system to code generation. The reflection of an expression be the same sequence of tokens as if you splice that reflection back to the code. Gives you access to operations not yet available by the semantic reflection in 26. What's different here? Oh, just the execute flag. Sorry, why does it matter if there are 103 candidates, though? Like, you still use the one you want. Like, in practice, I feel like this has never been an issue. Print line, let's print like vec. Yeah, but like if I have 117 candidates, right? And like let's say it's a function, like then like they're all just different function names instead. I guess then that would make compiling faster, right? If it doesn't have to sift through. What? Expected string found bool. The trait bound I32 bool from stir bool is not satisfied. Right, so like the error is actually useful. Named factory functions and constructors. Different factory functions. I wonder how it works for operators, because operators can't be overloaded in the traditional sense, right? You have to overload add, and I go say like this is not implemented for this trait, right? What's the error for unread map for that one again? So with this one, not that one, for this one, no matching function call for unread map int bool, bracing closed, and isolated list. I mean, this is just a fucking template thing. That doesn't help, but whereas here it's like it tells you should use, what does it though? It says it expected well, help. Involves every single construction from unordered map. The C++ error doesn't look this longer. But like, why does the compiler even need to list all of them? I genuinely don't understand, because like, look, let me explain this first. If you look at the C++ example, right, it says no matching function call for what you gave it, right? It says this is what we have here, and you're trying to call the constructor with a brace enclosed in a initializer list. There's no matching function call. Here's your input. Okay, there's 17 candidates. I'm going to list all of them. Right. My argument is you don't have to list all of them, because like, look at Rust. What does Rust do? Rust says that hash i32 bool is not satisfied because you have stir bool, right? So again, it shows you what you gave it, and it says this isn't satisfied. And then here's a line of code, and then it says that the trait is not implemented for hash map this, right? And then the trait from stir bool is not implemented for hash map. I mean, this kind of just it's not the same thing. Well, yeah, just help. But i32 bool is implemented for it. From right, yeah. So okay, actually, to be fair, so it tells you which you can use. So this is the thing. So this is the helpful part of Rust, of the Rust output. There's only one trait implemented for it. I mean, compared to C++, obviously. Like, yeah, so it is the same error, but from what I understand, because it's only one implementation for the trait, well, for this thing, you don't get the list of 17 different things, right? So that's quite handy. Right. But counterpoint, C++ shows you the other options. With Rust, you don't have that. You only see the only valid option based on what it guesses hold on. Why are they casting behind? Oh, there you are. What's wrong? What's wrong? I went to feed them because like it's already 8:42, but there's still lots of food in their bowls. But I don't know like if they expect me to feed them at a certain time regardless, and that's why they meow. It's also raining, to be fair. Hello. Okay, let me clarify. Suppose that instead of suppose that Rust's equivalent of the 17 overloads was 17 different functions, right? Different static functions. Hello, you can't be at the table, I'm afraid. Come on. Oops. There you go. So to kind of voice what I'm saying here, yes, C++ will give you 17 different overloads that you don't care about, right? But it's still, with Rust, if you, instead of having overloads, you have different functions, right? If you use the wrong function, you don't get the other options for the other functions that are similar and might be what you're looking for. You just get nothing. You only get what you were meant to get to that function, right? And C++ does the same thing. Like it tells you, yo, I didn't expect this. I wanted something else, right? Whereas with Rust, it's like, what? So like with C++, like if I try, hold on. But then my concern is that using the wrong option by accident doesn't tell you of the other options. You have to instead remember a bunch of different function calls. Function names. And that is arguably more so due to bad API design and abuse of overloading than overloading in of itself. Hold on. Name tidy functions instead of constructors. Yeah, that's what is that not what I said? Right? Use a lot of warnings and cover damage into your header. Use up and down arrows through standard constructors is basically useless when writing C++. That's true. Compiler errors on documentation. There are other tools to help you find the right function to call. Yeah, so why does C++ list all overload options when you get an error? You can just refer to the documentation to verify the overloads you're looking for. But yes, this I understand. What else can it do? Not print all the options that are useless to you anyway. It doesn't have to be so verbose. yeah. What Volatile said. Yeah, but then you know what the arguments are, right? What they have to be. So like you either have too many or you don't have any. Whereas with Rust, well, with having no overloads, you just have. You don't know what types were introduced or why it failed. Right. So if you just have one. Trait-based overloading. If I were to unlearn overloading, I'm trying to think like what does the language look like without it, right? I mean, you have Rust, yeah. Concept maps, what are those? Visual diagrams use organized overloads featuring nodes connected by labeled arrows explaining relationships. Huh? Programming? Okay, I guess it's that. I don't know. Some abstraction, I guess. What is the actual value here? Say I have a function move that takes a float x and a float y, or f32x, f32y, and is void, right? And then auto move, which takes a vec2, f32, amount, steps, let's say, I don't know. Function loading it must exist as well to support operator overloading and to help with certain kinds of generic code. It's not especially good at either of those. It's also a band-aid for the misfeature in the language that constructors exist and cannot be named. Yes. Yeah, that is true. That they cannot be named and all that, but and also cannot return optionals. Like you could have X and Y be generic, because that's fine, I guess, right? Yeah, because then it's like the trait system that Rust has. But like with a vec, Why move path? A series of positions is a path. Would you be opposed to move 5-3, move, hold on, C++, move 5-3, and move vec2 at 32, because it's like at some point, because I've seen stuff like write U32 from Rust, and it feels wrong. Why is it not write U32? Actually using the type. Move to point, move by steps. Well, no, that's different. That's not what. It's not move to point. They're both move by. Right, so it's more overloading through generics. Huh? No discard. Man, these ones are so annoying for like this. Like, is there a way to just like ignore that? Like conceptually, it's the same thing. I specifically like overloading when it is the same thing, like the same concepts, just on different inputs, right? Like in the same way that you can move 2 steps and moves 5 steps, right? Oh my god, bro! This guy's actually so annoying. It's what's this? Translate physical address to virtual address. Translate virtual address to physical address. No, there is a basis. If I can move 5. That is true. It does, but like, it's the abstraction. Like, it's just less verbose. Translate ver to physical. It should be to physical and to virtual. Or physical from and virtual. My point is, the input can be inferred, right? The output is what determines the function name. Move, if move player, or like if move steps simply moves a player, then the input shouldn't matter as long as it can be read as something to move the player by. This is my case for overloading. Right? And we can already overload with generics, but it's going a step further and supporting less trivial things, like both, again, xy and vec2. That wouldn't be a good use for overloading. That's my point. That's what I was saying. Yes, I agree. So perhaps the solution is stronger generics that can yes, I agree. So might it fuck me. I absolutely agree. Agree. So I'm wondering how a generic system can support the intuitive things. Fuck me, can support intuitive abstractions like both move xy and move vec, or like move by, sorry, xy and move by vec. Bro, I feel like I'm just in a perpetual cycle of being misunderstood. We'll see if that happens already. Does it? Because I don't like overloading in how you can abuse it. So if you can have that in a generic system, but like have it constrained, but then still allow what you would want to allow, I guess that's the goal, right? So there's a caveat. What? It's not the same. You can't pretend it is. Bro. Designated in it. But there is because it raises an interesting point. What actually are function arguments, function parameters? What if function parameters were in of themselves a struct such that I can pass either the struct members or the struct, so I can pass either either a construction of that struct, like move by dot x equals three, or the struct, or an object of that struct instead. Move by vec. But probs with, I don't think C syntax accommodates this well. Does it also send it out? Oh yeah, no, compile doesn't. But it shows errors, which is what you want. I think I need to write. Oh my god, bro! I don't want to write my Rust. I really don't. Default arguments, by the way. To be fair, I do have less of an issue with overloading in Rust because you can achieve it via generics, or like via traits or generics, whatever. Although I think what I mean, I've like what I said here. This is something I thought about before. I just need to think of a way in which it can be implemented in a nice way, like it's a very different way of thinking about even like structures, or like the way you go about creating structures. Kind of, it'd be easy to just write it and show it, but like the idea is that the arguments of move by themselves fit into a struct. And so rather than, so that if you want to, you can have move by xy, right? But you can contain those elements in a struct and pass that instead around, you know? And I mean, you can emulate this by always using struct members for everything in a function. But then it's like, are there any limitations there? I need to explore that further. What? Right, so the solution is having static methods over constructors and trait-based overloading. Although, would you call trait/generics overloading? Or is there another term? Also, what do you think about default arguments? I suppose in Rust you can use option instead, right? So option like that would be option T, whatever. In theory, sometimes they're not easy to make work in these languages. Sorry, why is all going on? I think you're not with having with keyword arguments, to be honest. You can, but it won't be defaulted. Yeah. But it is a compelling way to do it. Like if you implemented default through optionals, yeah, then it would mean that you can implement it. Default values. The only place Rust has defaulting is in struct fields, so similar to C++. Wait, does it have struct fields? You can kind of use that. Oh yeah, wait, does it? Yeah, it does, but you have to use it, right? I think. Wait, does it? I'm not even sure anymore. It might do. It seems to be that you can kind of use that to get both keyword arguments and defaults for functions with verbose. But for something that you know that often is fine. It is something I use quite often though. And defaults. What are keyword arguments? So let me go back to this server here. Point of research. Function parameters are can just be structs. That way you can support both move x equals 5, y equals 3, for instance, and move vec 2 without needing overloading. I'll pin that. Icon pin. Great. I should reply to this and do like /pin, I think. Yeah. Default arguments could rely on option type thing, or perhaps even could you bake it into the type? You can, but then like you can't overload, right? Not overload. You can't reassign. I mean, different things. Yeah. This prevents needing to bake the default value into the function type itself. Oh yeah, cool. I totally think they pair well with named arguments though. You could have something like foo bar equals default. Right, yeah. Although my bigger concern is how you handle, but more importantly, how do you, if you have named args, are those parts of the function signature? It's fairly common in like a game, though, you know? Kinda. Maybe not. Yeah, I don't know. I find that like game stuff tends to have a lot. I wasn't. I want. Builds come up a lot when you have config like structs, you want to default to, and then change just like one or two fields. Yeah. The issue with just using a struct is that you can't handle errors or process special inputs. I would prefer to never construct a struct explicitly. Only within the class's static constructors. Derive defaults. Is this a thing already? Oh, this isn't a thing yet. Ugh, fuck me. Dude, Rust is just weird. Also, why does it need to be done through a macro? Yeah, I mean, anyway, so designated initializers, literally. If it's what I think it is. Well, these terms are so fucking weird. Designated initializers, aggregates. Okay, yeah. Like, why is there a trait? Required. Does it not exist? I thought required existed, no? Window, new. Title equals my window. Size equals vec2 new. With x equals 800, y equals 600, and then pos equals vec2, x equals 0, y equals 0. Default. Explicit type inference. No need for new, since types are uppercase anyway. Standard size t size equals delete. Anyway, age cannot be default initialized. Markers required on line n in file m. That's cool, actually. This can be achieved by not using constructors. I say just put everything into function call syntax. We don't need a separate, we don't need the separation. But this might be beyond that. Anyway, yeah, there you go. Carbon, by the way. There's this talk here, not really sure what it's about. The apparent awfulness of carbon. Okay, great. That's a that's a good start. Yeah. So there you go. There was a 3.5 hour video where I watch a video and then I go and talk on the Discord server for like a long time. My takeaways. Overloading is my teeth, man. Look at that. I need braces. My teeth. Overloading is good. We like overloading, and we use it for generic programming. It's a question. The real question is, how do we get generics to cover everything we want with that, right? Like if I say move by an X and a Y, right? Like I want to move my position with an X and a Y. I should be able to give any input that makes sense, right? And have that be able to be processed. Whether I pass X and Y as two separate arguments, or whether I pass a vector, right? A vec2 with an X and Y, or whether I pass, I don't know, what's another example? Like some, I don't know, specific like string coordinates formats that my library happens to support for some reason, right? Like I should be able to do all of those via traits, because I like overloading. I don't like how it's abused. Like in my projects where I've used overloading, I have not abused it. I've, like, for example, to give 2 examples I can think of right now where I've only ever used it, like for my binary library, is 1, constructors. Overloading constructors, because ultimately a constructor is the same thing, right? I don't care about overloading the constructor. Sorry, I don't care about giving the reason I like having named constructors isn't because they're named. In fact, I don't even necessarily like named constructors. I just like static constructors that return stuff, because ultimately you're still constructing, right? You're still constructing, and the argument should be different. That's it. You're still, because you're constructing, the function should be just a constructor. I think having like different names for the same thing is more confusing than it's not, and it's not a good reason to not have overloading. I think overloading is genuinely useful there, and it should be in the language. The other use is for my binary library again. I have read and write functions for different types, and like this is like writing to a binary file, okay, like a hex file, hex data. So imagine that, right? So you can write integers of different sizes. You can write strings, and you can also write structs, and you can also write floats, right? So all of these are overloaded. I don't have write string, write float, write int. I don't have that. I have write, and then you can pass in your type argument, or it will infer it from what you pass into the function, and that's fine. And that uses generics, and like if you do that in like a Rust model, it'd be called writable, right? Now the issue with C++ is it doesn't have traits. So that's why the overloading has to exist in that sense, as they said in the Discord chat. But that doesn't mean you can't use overloading to good effect in C++. It just means that you have to be more careful about it, because the compiler will not stop you from doing stupid things. I would never have an overload of a function with a different output, for instance, unless it was specifically a generic function that returned an output that matched the input. Right? So like say I have add, like an add function, pretty simple. If I take 2 floats and add them together, I expect a float. If I take 2 integers, like u32, add them together, I expect a u32, right? Or an overflow error. So that's that, right? I want... That's the only case where I would have different output return type. But like for what someone else said to me, right? In the Discord chat, where they said they had like a virtual address to physical address, and then also physical address to virtual address, and they have the same function name translate for that. That's a horrible example, because then they're different things. You know, yes, like they're both translating, but like the actual process that's going on, one is a physical to virtual, one is a virtual to physical, right? It's different. Now calling it translate physical to virtual, and then calling the other one translate virtual to physical, that's a terrible name as well, because you can infer from the input what it's doing. Instead, call it like to physical with the virtual input, or to virtual with a physical input, right? Then you have that. But then it's like, oh, but then what if I have like loads of different I don't know, like what if I give some invalid input, right? And then I have like loads of different options, like overloaded options. What well, I don't know. Like, I mean, how does Rust work? Right? Let me try something with Rust. Like if I do execute in Rust, and I do function main, and I say print line, actually not even, but I'll do function main, and I'll just say, well, it's gonna be a fucking warning if I don't print it. So we'll print it, and we'll say 5 plus. Well, no, that's not a good example. Like an example where I would get like a list of different options. I'm trying to think now. Constructors is one, right? Swift. I wasn't showing my screen anyway, but sorry. So, what's an example? Constructors are one. You can't do that in Rust, right? But like, yeah, like how do I have overloadable constructors? Like, I can use traits, right? So, take. Yeah, so like, for example, in my library, you can construct a file, like a binary file, from not a file, sorry. You can construct a binary data object that just like stores a vector or like a sequence of binary, bytes of binary data. And you can load that from a file. You can load these seagulls from a file. You can load it from an address in memory. So like if I have like, let's say I want to encapsulate some copy some game memory from like a game at runtime, and then copy that memory into a buffer and store it. I could do that, or from a span. I think those are the three options. You could add more, but those are the three ones I support so far. And each of those is an overload, right? But like I don't have like from file, from span, whatever. Like no, I just have from, and then depending on what you pass in, you have those different options, right? And then in that case, like those are useful, right? So then like if someone tries to pass in like a string, well, first of all, there's the risk that the string will get interpreted as a span or as a pointer into memory. That's a concern. But like let's say that I pass in a standard string and that had no like implicit conversion, because you wouldn't want implicit conversion anyway. In that case, you should get an error that says this isn't supported, but these are. And then it lists the three other overloads. That's where listing the overloads is useful, because they're all useful in that case. So that would be a good example. And I'm sure Rust has this, right? Like, because Rust has the from function. So I believe you can. Let me test this in the playground before I send it in that Discord server. So like say I want to print whatever, I mean it doesn't matter, but let's say it's this, whatever, just so I don't get a fucking compiler warning. Let's say I have U32 from 5. That's not going to function cool. The trait bound U32 from I32 is all satisfied. Okay, so first of all, it's weird that it even assumes that that's a thing, but... Okay, yeah, here we go. Perfect, perfect. Check this out. This is the type of overloading I'm aiming for. Here, when it lists the options, they are all actually useful. They also benefit from not having C++'s horrific template expansion, horrific verbose template expansion. Yeah. This is how I use overloading in C++. I'll use it for constructors if they initialize the class in the same conceptual way, like in the same way, just from different types of input. Yeah. And I also use it for stuff like read U32, standard endian big, read standard, or like read, I'll just skip the float, whatever, read F32, or F64, standard endian little, read standard string, yeah, 4, first arg, size. This is a library for parsing binary data. And likewise, write some U32, write some string, hello, 5 U32. Yeah, write 44.2 like this. I think these are the acceptable uses of overloading. And Rust does do a good job. With its traits system for supporting it. Just saying this now to clarify what I was talking about before, because I feel like there was misunderstanding. Okay, have I shown my screen at all? No, I haven't. Okay, so let me just show my screen here. So have a look at this, I guess. If you try to do U32 from 5, you get an error. 5, by the way, is implicitly an I32. I hate how that works, but it's just an easy solution. And then notice how the compiler actually does list the different options you have. Right, as C++ does with its overloads, but C++ abuses it. That's the difference. It abuses its overloads. But even in C++, you can use overloading. Yeah, but yeah. But like, it isn't bad in C++ either. It's just that you have to not abuse it, right? Also, again, the template expansion is horrific, but besides that, you know. Yeah, so like in my library, for instance, I have like reads, U32, U64, like these are all overloads. And also I have writing. These are also overloads. And there are some issues with like, again, like a const char could be whatever, but what are your thoughts on AI? Okay, time to leave that discussion. So, when I'm designing my language, true, I will not support overloading. I mean, I had no intention of supporting overloading. I mean, like not overloading in the C++ sense. I'll support overloading through traits or through like APIs, inheritance type thing, like whatever trait-like system that I implement, which I haven't decided yet. I do have issues with Rust. I think what my next video will be going back to Rust and trying to make my most of the language and like really noting my gripes with it. Because the more I use that language, the more I can come to terms, well, not come to terms with, but the more I can like understand my issues with it. Same with my C++ game dev project. But before I do that, I need to config NeoVim. So that will be the next video actually, because I can't do shit without an IDE that actually works. Not an IDE, an editor. Jesus Christ. I need to piss, by the way. That's why I'm shaking. I'm not mentally ill. I do need... Yeah, sorry. It kind of is an IDE, though, because like it has a debugger. Well, it will have a debugger, and it has an LSP and everything. I just need to set it up myself. Similar to how like VS Code is. Not really an IDE, but once you get all the extensions in, it basically is. But yeah, that's good. Default arguments is the main thing. I'm still same opinion on macros. I don't like macros. I'm gonna find every single way to possibly not have macros because I like a language that has intentional design. It's a useful feature, but I just don't want them. I think if you put macros in your language, you're setting up your language for failure. That's why I think Rust will not survive. Obviously, it will survive if people keep using it, whatever. But I think Rust will be replaced in the same way that like C was replaced. Not even in the same way that C++ was replaced. C++ being replaced is more an issue of like fixing issues that it can't fix due to its bloat. Philosophically, C++ is pretty good. It just suffers from its backwards compatibility issues. Rust isn't a C++ replacement, and that bothers me. I really wish it was, because I don't want to use C++. I really don't. You know, I love the language, despite its flaws. I love, you know, what people have like done with it to like make it better, and I find it really cool, a really good case study as well. But I don't want to use it. It's really not nice to use. It's not a nice language to use. And Rust just doesn't do enough, like anywhere near enough. So I'll try making something in Rust or multiple things, and I'll come back to my thoughts on that so I can compile them to like a blog post or something, because I really need to like justify why I don't like Rust. And macros are just one reason why a language down the line could come and improve, because Rust is going to have issues where, hold on, I can do this with macros, but now the Rust wants to add this language feature, so now these macros are obsolete, but I can still use them if I want to, you know, and like having defaults and stuff is like there are friction paths to do convenient things because they're added in the future because they weren't, you know, like thought about initially, because the Rust team didn't think that deeply about the features they wanted to add, you know, like stuff like that, which will put Rust in a very similar state to C++ in the even not so far future, honestly. So I look forward to another language coming along and truly replacing C++ in the way that Rust can't. Like the best thing about Rust is by far the bar checker and the compilation, and you know, and like the way that it compiles, like not even the way that the compiler, well, yeah, safety, right, safety, but like specifically the Rust compiler is awesome. The way it catches errors and stuff for you is awesome, and it suggests fixes is awesome. Like it's a really good example of how a compiler can be helpful for the programmer. But at the same time, it's kind of overly restrictive. The bar checking is cool, but it just completely sucks for any foreign, well, some FFI, foreign. What does FFI even stand for? Foreign something interface? Foreign function interface, yeah. FFI sucks in Rust because you have to use it in safe everywhere. Yeah, so like that's the downside. But otherwise, it's really cool. But like the other parts of Rust, I don't like patch and matching is cool, but it can be better. Tagged unions are cool, but also like kind of potentially too convenient, or like the way they're built aren't like integrated into how structs work. And that's weird. Like they kind of overuse tuples. The overuse of tuples, I hate it. Language it's. Keep in mind, it's not just like, oh, I don't like tuples, but it's like, yeah, but Kojo, but tuples are just like a convenient thing. You know, people will still use structs when, you know, when names are should be used, except they don't. They don't. So that's awesome. I wish they did, but they literally just don't. They use structs when they should. And the macros, I hate the macros. It gives you stuff like Leptos and Tokyo, and then like everything's just horrifically bloated with macros, and it makes learning these things hard to use. The fact that like Bevy can get as far as it has using just macros, like it's commendable, but it's also a bit like, damn. Like, okay, I mean, Bevy's actually not that bad. Well, I mean, actually, I don't know. I haven't used Bevy. I just know that it does make use of macros for its entity component system. But just like, do you really need macros to have an entity component system like layout for like a game engine? Just doesn't seem smart. Anyway, yeah, so it's almost 10 o'clock now, so I'll probably get on configuring my LSP and stuff, and it's already configured, but it just doesn't quite work fully, and also getting a debugger working for NeoVim. I'm in a really bad state right now, like, fucking, I'm not happy with the languages I'm using, so I'm building my own language. I'm not happy with my editor. I tried Emacs. I was like, hold on, Emacs is low-key worse. So now VS Code sucks. So now I'm on NeoVim. Like NeoVim's cool, but setting it up is such a pain in the butt, right? At least I'm happy with Arch Linux. Except it's also kind of not ideal, but yeah, who knows? Maybe by the time I die, I'll have made my own operating system and my own kernel and my own fucking editor and my own everything. At some point you're going to say, you know what, this is good enough, and make do. But for some reason I just can't do that. Honestly, this needs to be studied. Like, why can I not just use things in the same way that other people can, and in the same way that other people can, and just get by and be fine with it? Like, if I don't notice something that bothers other people, that's a blessing. Because like the moment I notice it, you know, it's over. Like suddenly I can't do that thing anymore. It's actually tragic. It's probably why I bounce between like different hobbies so much, because like I have fun with something, and like the moment I hit like a barrier that's like, oh, this could be better, then I either fix it or I get stuck, and then I just jump ship, literally. And like that's why I have so many different hobbies, because I just can't stick to something. Like with video editing, you know, I had a whole YouTube channel where I would edit videos, but then I hit a wall with my video editor because I can't use Premiere Pro on this computer. because it's too laggy. Plus, I also don't have Premiere Pro. I'd have to buy it or pirate it. I can't use DaVinci Resolve because, again, this computer's just not strong enough. So I just can't edit videos. Like, yay. I could use Shotcut, but then I can't edit it to the way I want to edit it. So that's literally just dead right now. Like that hobby is dead. You know, like language learning, you know, like the tools for language learning. I have issues with Anki and Mochi. And so it really hurts my motivation for actually doing the thing because the tools I have are inadequate. And yet there are some people who or many people even, who can get by using these inadequate tools, and they do fine and they benefit hugely. So like, it's not like you can't benefit from faulty tooling. It's just that I specifically have an issue with doing it. And it actually gets in my way. On the one hand, it does mean that I can be a good insight into the way things can be better, right? If I was like hired in a company, then I could contribute my perception, you know, my perceptivity to improving systems. So then, you know, down the line, or like in the present, people ask, oh, why do you care about that? You know, it's good enough. But then down the line, people be like, oh, thank God this guy did this. You know, like life is so much easier now because this guy did this and didn't listen to the people who were, you know, stuck in their own bubble. But, you know, for that to happen, I need to get hired. So, and then like, how do I develop these things if the tools I use to develop things aren't good? So that's why I'm focusing so much on like NeoVim, my own programming language, like switching to Linux and like learning how to Rice Arch. So then I can have tools I need, because like those are those are the most important. If I have a good workflow set up, finally, I can finally like stop being held back by that and just focus on actually doing other things then, and like I can build my way up. So that'll be awesome. That would be awesome. Yeah. Anyway, subscribe to see more developments in the Kojo's Bizarre Adventure. That's the name of the channel.